Hello, good morning everyone. Welcome to BYJU'S exam prep. So today we are again conducting a very important session for all of you. As you all are aware that the HAL 2023 recruitment notification came and the exam date is already announced. So the exam date is 9th of September. So for that, because the time period is less, so what you can do is you can just go for the mock test, right? This is the time where you need to practice a lot because we have to solve 150 questions in the 160 minutes, or I think vice versa, 150 minute 160 question, and out of which the 100 technical questions. So good morning Ashok, and I am going to cover the subject that is electromagnetic theory, and I will cover the portion which will be relevant for the electrical and electronics branch growth. So whatever your branch would be, you can join this session because it is going to be a common session for all, that is electrical and electronics. So good morning Jayesh, good morning Mansvi, Ashok. Voice is perfectly fine. Okay, you can just increase, you can check the volume of their thing. I can. I am able to hear my voice clearly through the mobile, so there is no problem at all, right? So let's move into the next part, that is the scholarship test, because when you want to prepare for the GATE exam, definitely you want a perfect material, perfect course from any institute with the affordable price. So to get that affordable price, we always conduct a scholarship test to support the students. And for the GATE exam, those who are willing to prepare for the GATE exam, they should definitely go for this scholarship test. And when you appear in this scholarship test, not only you prepare for the test, you also come to know that what is your level at present, that how many questions you are able to solve without any preparation. And if you prepare with our team, our batch, then you will definitely get the more guidance, and specific area where you are feeling weak, you can improve that. And for that we have the scholarship test, and you, if appear in the test, you will get up to the 90% off. And every Sunday especially we conduct this scholarship test, and that will be from 9 a.m. to 9 p.m. The window will be open. The registration link is given in your description, you can see, and from there you will be able to appear for this test. So quickly guys, please share the session with all of your friends, because right now this test is very important. The number of seats are more in HL this time, and you cannot miss this chance. So just share with your friends. Okay, so are you guys ready? So let's go into the next one, which is about the scholarship we have discussed. So now it is the workshop. So you can attend this live interactive workshop with the Richa ma'am, and 5 steps to triumph in the GATE 2024. So 16th of August, Tuesday, of I think Wednesday, yes, Wednesday, because 15th August is Tuesday. So 16th of August, 7:30, you can join the workshop. Again, to join the workshop, the link is given in the description. So everything you will get in the description. So whenever you come into our platform, always check the description of every videos, because you will definitely get many things in the video link. Okay. So this is the first question. So solve this question. So try to how to prepare for the general study. General awareness part you have to study just recent current affairs you can study. Okay, and some basic standard like a modern history, you can prepare geography, you can prepare books and authors, you can prepare important dates, you can prepare. But because it is not the, we don't have the enough time, so I will suggest you to go with the current trend, that is the last 6 months global events and the national event. That would be sufficient to score minimum marks for in the current affairs, because you might be prepared well in the technical part, so better to stick with that and don't prepare the things which you haven't prepared. So we have 20 days, 25 days, and in these 25 days you can go through the current affairs and some important parts like a modern history or geography and important dates and books and author. So guys, are you solving this question? Answer this question. Two electrical dipoles P1 and P2 are placed at 0, 0, 0 and 1, 0, 0 respectively, with both of them pointing in the Z direction. Without changing the orientation of the dipoles, P2 is moved to 0 to 0. The ratio of the electrostatic potential energy of the dipole after moving to that before moving is. Okay, after moving and before moving, you have to calculate the ratio of potential energy. The ratio of potential energy. So I'm getting the answers, but unfortunately, I'm waiting for the other answers, because I don't think that the answer which you are giving, honestly, that is correct. So read the question first. Okay, then answer properly. It is the asking for the potential energy, right? Potential energy. Yes. Quickly answer, Ashok. So all of you are giving B or C, Pratyusha also. Okay, so now the answer for this question is just because we are preparing according to HAL exam. So for HAL exam, you should know the important relation, and you cannot go into the depth of every question. Like, I cannot go into the derivation part and how this formula came. What you should know here is, whenever you can calculate the energy for the dipole, for a dipole, the energy, the potential energy is inversely proportional to 1 upon r cube. So this is the relation that you should know. Okay, now tell me the answer. Now tell me the answer. Yes, most of the questions we can expect theoretical. Prashant, definitely we can expect the more theoretical questions and some questions which is directly related to the relations, like this. Just you need to have the relation with you. You don't need to put the values in the formula, and you don't need to calculate, because the calculator will not be allowed. So you will get the questions where the maximum things will get cancelled. You will get the questions like, if I'm increasing one parameter, then what will be the effect in that other parameter? Will it increase, will it decrease, will it increase by factor 2 to the power n, something like that. So yes, now you guys are getting the right one, because we have to calculate the ratio of the electrostatic potential energy of the dipole after means we have to write the U2. Okay, that's after and u before is equal to 1 upon 2 to the power 3, because the distance is now 2. With respect to 0, 0, 0, the distance is now 2, and here the first distance was 1. So previously the distance was 1, and after the distance become 2. So it is inversely proportional to r cube. So simply this is nothing but the 1 raised to 1 is to 8. 1 is to 8. So option D will be the right answer. Okay. Coming to the next question. Solve this one. An electric field ER, where alpha r cap plus beta sin theta cos phi phi cap exists in space, what will be the total charge enclosed in a sphere of unit radius centered at the origin? An electric field E, vector E is equal to alpha r cap plus beta sin theta cos phi cap exists in space, free space, and what will be the total charge enclosed in a sphere? This test is for both EE and EC. This is common part. This particular questions are common for both EE and EC. There will be some questions specifically for EC also. So just stay with me for the next half an hour. I will cover the questions for the electrical and electronics both. And this part is also there in the syllabus of electronics. So you cannot skip this part. Okay, obviously they have mentioned the syllabus as the GATE 2023, but in the GATE examination also they ask the question from the electrostatic and magnetostatic. So because we want to calculate the total charge enclosed, so we know that the total charge enclosed is equal to integration over the closed surface d dot ds. Okay, integration over the closed surface d dot ds is equal to flux passing through the closed surface, that is the Gauss law. So from here we know that integration over the closed surface, the d can be written as epsilon naught into E because it is free space, and the differential surface because it is in the unit radius, centered at unit radius. So towards the radius, that is AR cap, and this is R square sin theta d phi. Okay, so you will get epsilon naught, and when you take the dot product you will get alpha, and then R square, then sin theta d phi, correct? Integration over the closed surface. So you are getting alpha into epsilon naught. Now it is saying that it is the unit radius. So it is saying the unit radius, so r is equal to 1. Now integration over the closed surface, that is the integration over the surface phi, limit from 0 to 2 pi, and integration theta from 0 to pi. This is sin theta d phi. So what is the value of this integration? This is nothing but a solid angle, which is 4 pi. So we will get 4 pi alpha epsilon naught is our final answer. That is option A. Option A would be the right answer for this question. Okay. Now coming to the next one. This is the question for mainly for the electronics student, but yes, this can be solved by the electrical student also, because the wave propagation also comes for the electrical student, if you are following the ESE syllabus. But yes, according to the GATE syllabus, this won't be the part. So here in this question, it is asking that the lossless magnetic dielectric medium, and we have to find the corresponding magnetic field if the intrinsic impedance eta naught is for the free space. So we know that if you want to write the magnetic field, we should always write in the standard form. This is H naught because it is lossless. So it is cos of omega t minus beta because the wave is propagating in the positive z direction, and AH cap. So how do you calculate the H naught? H naught is nothing but the E naught divided by eta naught. E naught is 5. So 5 upon eta naught you will get as ampere per meter. Now another thing which we want to calculate is the direction. Direction of magnetic field is direction of propagation cross product with direction of electric field. Okay. So what is the direction of propagation? The direction of propagation is z, and the direction of electric field is given as x. So az cross ax will be ay. So you will get ay. So now you have got 5 upon n naught, and the rest of the things are already given. Omega is 10 to the power 9 and beta is 20 by 3. So if you will substitute all the values, what you get? 5 upon n naught. So 5 upon n naught we should get minus 10 to the power 9. This is yes. So I think the answer is 5 upon n naught only should be there. Is there any other parameter which we are leaving? Okay. So here the answer would be 5 upon n naught only. So this 2 will not come. 5 upon n naught. This 2 will not come. Yes. Because there are no other parameters given. So the value of 5 is maybe the typing a mistake. So yes, we are getting 5 upon n. We are not getting 2 in the denominator, right? Yes. So let's move into the next question. The skin depth of a non-magnetic conducting material at 100 megahertz is 0.15. The distance which a plane wave of frequency 10 gigahertz travels in the material before its amplitude reduces by a factor of E inverse. Yes, tell me. So we know that this skin depth delta is inversely proportional to the frequency. Okay, it is at 100 megahertz that skin depth is 0.15. Then at 10 gigahertz, what will be the frequency it is asking? So delta 1 upon delta 2 is root over f2 upon f1. So the frequency is 10 gigahertz, so 10 into 10 to the power 9 divided by 100 megahertz, so 100 into 10 to the power 6. So when you will solve it, you will get 10. Okay, you will get 10. So the delta 2 is delta 1 divided by 10. So delta 1 is 0.15. So divided by 10 is 0.015 millimeter. So the answer is option B. You don't need to multiply by 10, it is divided by 10. It is divided by 10, not multiplied by 10. Okay? It is not divide, it is multiplied. It is not multiplied, it is divided by 10. So answer is option B. Now answer this question. So these are the questions for the electronics mainly, but and again I will come into the common area where the electronics and electrical student both can solve the question. Yes, the overall PDF you will get in the Telegram group. The final PDF for all the questions of this mini mock test you may get in the Telegram, but the answers and for that you have to stay with us because the key for the PDF will be provided in the end of the session. So you will not be able to open the key. We will not be able to open the PDF if you don't have the key. So definitely you have to attend throughout the 3 to 2 hours. A lossless transmission line has a characteristic impedance of 100 ohm and inductance per unit length is 1 microhenry per meter. If the line is operated at 1 gigahertz, then what is the propagation constant? What is the propagation constant? So it is asking for the beta. Beta is equal to omega by Vp. Okay, and it is also given as omega root LC. and the characteristic impedance for the lossless transmission line is root over L by C. So if I multiply these two, equations, what we will get is omega into L. So we want to calculate the value of beta, which is omega L upon Z naught. Omega is 2 pi into F, which is 10 raised to power 9, 1 gigahertz. L is 10 raised to power minus 6, which is 1 microhenry per meter, and Z naught is 100. So what is the answer? So it is nothing but a 2 pi into 10 to the power 5 radian per meter. Answer is option D. Right? So these are the two equations that you should know about the lossless transmission line. For the lossless transmission line, these are the two questions. Option is D, not C. Okay, wait, yes, correct. Option is C actually, calculation mistake. 7 minus 6, that is 1. So 20 pi. Yes, option is B. Now answer this question. When a load resistance RL is connected to a lossless transmission line of characteristic impedance 75 ohm, it results in a VSWR of 2, then the load resistance is. So VSWR is given to you, that is 2, and the load resistance you want to calculate. The load is resistive in nature. All the load resistance are given as greater than the characteristic impedance. Okay, from the option you can observe. Okay, from the options we can conclude. Okay, we can conclude that the load resistance is greater than the characteristic impedance. Okay, and resistive in nature. So when the load is resistive in nature, then what is the VSWR? The VSWR is given by the impedance which is greater, so ZL upon Z. So you want to calculate ZL, so this is 75 into Z0, which is 2. So it is 150. So 150 ohm will be the right answer. VSWR means the voltage standing wave ratio. Okay, so voltage standing wave ratio. Now solve this one. A two-port characterized by a S parameter matrix, whether it is a lossless or reciprocal, you have to tell. So for lossless line, what is the condition? S11 mod square plus S12 mod square should be equal to 1. So if I calculate it, 0.3 square and 0.9 square is 0.90, which is not equal to 1. Hence, not a lossless network. But for reciprocal, the S and the S transpose should be same. So when we take the transpose of this, matrix, we will get 0.3 at an angle 0, 0.9 at an angle 90, and 0.9 at an angle 90, and 0.2 at an angle 0. So you will get the same. Hence it is reciprocal. So reciprocal but not lossless. Yes, and you can also use the symmetry property because it is a 2 cross 2 network. This is for the symmetry and reciprocal. Yes, option B. Now for the electrical student, mainly now the questions will be for both, that is electrical and electronics. Ready? So have you solved this? So answer I am getting is B. Okay. See, in this question, you have to calculate the magnetic field, right? And you know that the induced EMF is given by minus del phi, or in fact, I should say the flux linkage, the rate of change of flux linkage. So minus del lambda upon del t, which can also be written as minus n del phi upon del t. The induced EMF can be written as the I into R, okay, I into R, and minus n, and this can be written as n, this phi can be written as B into A. Okay, this can be written as B into A. Now the current, we want to calculate the value of B. Okay, so this current is dq upon dt multiplied with, or let's write multiplied with R, equal to minus n del upon del t into B into A, right? So this dt and dt will get cancelled, and we will get the dq, which is the current, and into R equal to n divided by n into A is equal to B, and you can ignore the minus sign because there is no option in the with the minus sign. So what you will get if you solve this? So according to this, the B is equal to the charge, which is 2 into 10 raised to power 5, in fact the minus 5, and multiplied with R, which is 20, divided by number of turn, which is 40, and the area, which is 0.1. So when we solve it, it is 2 into 10 to the power minus 5 into 20 into 100 divided by 40. So it is 10 to the power minus 3. So the answer is option A. Yes, the answer is option A. Okay, got it? Now coming to the next one. What is the answer of this question? If the electrostatic potential at a point x comma y is given by V is equal to 2x plus 4y volt, the electrostatic energy density at that point. So the energy density is given by, the energy density formula is given by half epsilon E square, right? And because it is saying the free space, so you can use the epsilon. Now how you will get the E? So E is equal to minus of gradient of V. Okay, so this is minus of del upon del x of 2x plus 4y into ax cap plus del upon del y of 2x plus 4y into ay cap. So if you will differentiate it, you will get 2ax and 4ay. Okay. So when you take the mod, you will get 2 square plus 4 square, that is 20. So we are getting 10 epsilon naught. Okay, this is root over, and when you take the mod you will get the root over 20, but because we need to use the e square, so you will get 20 only. This is root 20, so you will get 20. So this is 10 epsilon naught. Okay, now the last one, solve this question. 2-point charges Q1 and Q2 are fixed with a finite distance d between them. So this is the charge Q1 and this is another charge Q2. Okay, the distance is d. It is desired to put a third charge Q3 in between these two charges on the line joining them so that the Q3 is in equilibrium. We have to put the charge Q3 so that the system is in equilibrium. Okay, the whole system should be in equilibrium. So what should be the value of the Q3, whether it should be positive or negative or irrespective of the sign or not possible at all? What could be the answer? What could be the possible answer here? See, if suppose you are putting the charge Q3 as positive, okay, suppose I put the charge Q3 as positive, then what will happen? This is the positive charge repel each other, force will be here, and this is F1, this is positive and positive, this force will be here. So that is F2, the force which is because of the charge Q2, and this is the force because of the charge Q1. So both will balance each other, both will cancel each other, so it will be in equilibrium. Okay, so you are saying that the Q3 is positive, that is almost true. But let's check one more condition. What if I take the minus Q3? Then this is the plus Q1 and this is the plus Q2. Okay, so this is positive, negative, attract each other, positive, negative, attract each other. So this is the force F2 this time, this is the force F1. Then also they are cancelling each other. So it can be negative also. So whether you put the negative Q3 or positive Q3, it does not matter. So the answer is possible irrespective of the sign of Q3. Yes, option will be C. Correct answer will be option C. Now guys, the Ashu sir will join you for the next question, next subject. Okay. So from the question number 11, Ashu sir will take the responsibility. These 10 questions, I hope that this is the level of the HL, that they will not go beyond this level. I have taken very basic question and little bit conceptual also. So now I will ask Ashu sir to join. Okay, so just give me 1 minute.
Hello everyone, thank you Saket sir. Hello guys, I hope you all are fine there, and now it's time for network theory and control system. Okay, I hope you are enjoying, and I hope you have solved some questions on EMFT. Okay, so guys, I have taken some questions on network theory, and you know that HL level is little less than gate. So the level of the questions is exactly with respect to HL. Okay, so let's start with the question, guys. This is the first question on your screen, question number 11. Okay, and you can see that the box in the figure A, this is the figure A. contains a linear bilateral passive network. So it's a resistive network. It is given that in the statement, the terminal 2 2 prime are short circuited and the voltage of 20 volt is applied at the terminal 1 1 prime. These two terminal are 1 1 prime and these two terminal are 2 2 prime. So it is shorted and 20 volt is applied here. Okay, the current I1 and I2 are, this current is 10 ampere and this current is minus 2 ampere. It means actually this current is going downward. Okay, the box is reconnected as shown in the figure B. Find the current I prime. This current I need to calculate, this I1 prime. Okay, I1 prime and the voltage across the terminal 1 1 prime. This voltage I need to calculate. So tell me guys, what is this voltage and what is this current? Do it fast. Let's see how many of you can solve it properly. Okay, and you have I'm giving you 1 or 2 minutes. Okay, not more than that. Do it guys, do it fast. Do it fast. Let's see how many of you can solve it. And don't forget to like this session. Okay, because there are total 15 likes and our target is 30 likes. Okay, so at least make 30 likes. So guys, tell me the answer. Tell me the correct answer. Tell me the correct answer. This question is based on network theorems, especially the reciprocity theorem and Thevenin-Norton theorem. Okay, this question is based on Thevenin-Norton and reciprocity. Think about it. It's a simple question. It's a simple question. Tell me guys, what should be the correct answer? Ashok is saying Bombay. Okay, let's see. Let's see what other student says. What other students say. So tell me guys, what is your answer? Okay, so let's try. Because this, 1 minute is more than enough for this question. Now we can see that if this is 20 volt, this current is given as 10 ampere. And in this direction, current is given as 2 ampere. Because opposite direction minus 2. So in this direction, the current has to be 2 ampere. Now, if I apply reciprocity on this, so this is the resistive network we have. And what I did is, I take this 20 volt on this side. So if you take this 20 volt on this side, and if you sort it here, if you sort this point and take this 20 volt on this side, then this current will be 2 ampere. But in this case, first of all, it is not 20, it is 10. So let's half it. So if you are taking half of that, this current will also become half. It means at 10 volt, the short circuit current is 1 ampere. So I found the short circuit current between terminal 1 and 1 prime. Between 1 and 1 prime, I found the short circuit current. So if I remove this resistance and if I short it, then the short circuit current is 1 ampere. And short circuit current is known as the Norton current. So we have found from this terminal 1 1 prime, we found the Norton current as 1 ampere. Okay. If you are looking from these two terminals, then the short circuit current or Norton current is 1 ampere. Now, what is the Thevenin resistance of this circuit or Norton resistance of this circuit? If you remove this resistance, now let's take it as a load. So if you remove this, by removing this load, what is the Thevenin resistance of this circuit or Norton resistance of this circuit? Now, how to calculate the Norton resistance? To calculate the Norton resistance of this circuit, you have to deactivate this source. It means you have to sort it. After sorting, what is the equivalent resistance of this circuit? That we already know from this circuit. We know that if you sort it, then between these two terminals, if you apply 20 volt, then the current is 10 ampere. What does it mean? It means the equivalent resistance is 20 divided by 10, that is 2 ohm. It means between these two terminals, the equivalent resistance of this entire network is 2 ohm. So we found the Norton resistance or Thevenin resistance. Since you are drawing the Norton equivalent, so this will be 2 ohm. So we found the Norton resistance. It means the equivalent resistance between terminal 1 and 1 prime. Now what you can do is, now you can connect the load. The load is 2 ohm. Between this 1 and 1 prime, the load resistance is 2 ohm. and I need to calculate this current I1 prime in this 2 ohm. This current is known as I1 prime. So tell me guys, what is I1 prime? So this 1 ampere will divide equally. Okay. So you can say that half ampere will come on this side. So I1 prime has to be 0.5 ampere. So there is only one option in which 0.5 ampere is given, that is Bombay. Okay. So answer is Bombay. There is no need to calculate voltage. Even you can calculate the voltage also. 1 prime voltage. So 1 prime voltage is this, half ampere into 2. So you will get 1 volt. Okay. So this question was very easy, and this was based on reciprocity and Norton theorem. Okay. So answer is Bombay. Let's come to the next question guys. Question number 12. Question number 12 on your screen is this. Consider the following network. So we have this network. Power associated with dependent source. How much power this source will absorb or deliver? It's not asked whether it will, whether you need to calculate absorb power or deliver power. No, it's not asked. Only the power, whether it is absorbing or delivering, it doesn't matter. You need to calculate what is the power which is associated with this voltage, this dependent source, the dependent current source. Okay, so that we need to calculate. Do it guys. Tell me what is the power associated with this dependent current source. Do it fast everyone. Tell me the answer. It's a simple question. It's based on nodal. Directly you can, or without nodal you can solve it. Just by using KVL, KCL you can solve it. Do it fast everyone. Let's see how many of you can solve it. Do it fast, do it fast. I'm giving you only 1 minute. Only 1 minute is allotted. Tell me the answer. Do it fast. Tell me the correct answer, and don't forget to like this session. Please like it. Especially those students who have not liked it. Please like this session. This will be your Guru Dakshina. So guys, Ashok is saying Bombay. Okay. Anyone else? Anyone else? Okay guys, let's try to calculate this. Now, first I need to calculate this current value and the voltage across this source. If you multiply this current and the voltage across this source, then you will get the power associated with this source. Now, how to calculate this current value? Obviously, this current depends on Vx value. If somehow we can calculate the Vx value, we'll get the current value of this source. Okay. Once you get this current value, you can easily calculate the voltage also, the voltage across this current source. And then you can multiply these two things, voltage and current, and you can easily calculate the power associated with this source. Now, how to do it? Let's first assume that the lower junction is the reference junction. I'm giving it ground, 0 volt. Okay. And we know that this branch current is fixed at 4 ampere. This branch current is fixed at 4 ampere. So this voltage has to be 8 volt. Has to be 8 volt. Now, if this lower potential is at 0 volt, then this point has to be at Vx volt. Why Vx? Because you are going from minus to plus. You are going in upward direction. So if you are going in upward direction, this voltage will be added. 0 plus Vx. So this point will be at Vx potential. What about this point? This point will be at Vx minus 8. This will be Vx minus 8 because you are going from plus to minus. It will give you drop. So it will be Vx minus 8. Fine. Now, we know that this current is 4 ampere. And we know that this current is Vx by 2. So if you apply KCL at this point, then the combination of these two current will flow through this wire. And the total current in this wire is 4 plus Vx by 2. And this current is downward, so it will give the polarity like this. Voltage across this 4 ohm will be of this polarity. And according to this path, if you calculate this junction voltage, it will be, you can start from lower point 0, 0 plus 2, 0 plus 2 plus this voltage. 4 into, this voltage is 4 into this current. 4 plus Vx by 2. And this has to be this point voltage. This point voltage we have already calculated as Vx minus 8. So now if you solve it, you'll get 2 plus 16 plus 2Vx is equal to Vx minus 8. Now take this Vx on this side. So you'll get Vx is equal to minus 8 minus 18. Okay. This is 18. So 18 will go on this side. So now you can easily calculate as Vx is equal to, tell me guys, it will be minus 26 volt. So we have found that Vx is minus 26 volt. If Vx is minus 26 volt, then this current source value is minus 13 ampere. Okay, this is minus 13 ampere. It means actually this current is going downward. This current is going downward of 13 ampere value. And what is this value? This voltage, if Vx is minus 26, then minus 26 minus 8, it will be minus 34 volt. This voltage has to be minus 34 volt. And you know that 13 ampere is going downward. So how much drop is there? This drop is of 13 volt. This drop is of 13 volt. Okay. Now, what is the voltage across this? If you calculate the voltage across this source, you can start from there, minus 34 minus 13. So this point will be at minus 34 minus 13. It will be at minus 47 volt. Okay. This is minus 47 volt. And this is 0 volt. It means the voltage across this source, upper point minus lower point, is minus 47. So this polarity voltage is minus 47. It means actually it is of opposite polarity. So across this current source is actually of value 13 ampere, and the voltage across this is of this polarity, and the value of the voltage is 47. Okay, this is of 47. Now it will deliver the power. How much power it will deliver? You can multiply this 47 into 13 and you can calculate what is the value. Tell me guys, what is this value? What is this value? So we have calculated the current value of this source and the voltage across this source. Okay. So voltage across this is 47 and current is 13. You can multiply them. Okay. And I hope you can easily solve this question. So I think it is Agra. 611. Okay. Answer is Agra. Okay guys, let's come to the next question. Question number 13. Question number 13 is on your screen. The Norton equivalent current and the resistance between X and Y. So we need to calculate Norton resistance and the Norton current between X and Y. Okay. What is the Norton current and Norton resistance between X and Y? Tell me guys. Try to solve it. So first let's calculate the Norton current. Norton current means short circuit current. So you can sort it. You can sort these 2 points and try to calculate this current. Okay. Tell me guys, what is the Norton current? What is the Norton current? Tell me. You can sort it and calculate this current, Norton current. We need to calculate this Norton current. What is this Norton current guys? Tell me. Tell me. How to solve it? It's very simple. What you can do is, okay, let's try. Please try. Please try. Everyone, please try. Please try this question. It's a simple question. You all can try. It's a very simple question, guys. Do it fast. Do it fast. So what you can do is, you can apply nodal. Let's assume this is at ground potential. I assume that this is ground potential. Since it is sorted, so this point will also be at 0 volt. Okay. Now you can see that if this is 0, this is also 0, then there will be current flow in this direction. In this loop, you can apply KVL. So current flow in this loop is 15 by 4 ampere. It means 15 by 4 ampere is coming from this side. If somehow we can calculate this side current, then these two current will be added and it will become IN. Now how to calculate this current? That we need to do. If you are assuming that this voltage is 0, then this voltage will become, you can see that if this is 0, this upper point will become 2V0. This voltage is 2V0. Okay, this voltage, because you are going from minus to plus, so directly you can say this voltage is 2V0. Now, how much current will flow in this direction? This point is 2V0, this point is 0. So you can calculate that this current is 2V0 by 5. 2V0 by 5. If somehow we can calculate this V0 value, we can calculate this current plus this current will be the Norton current. Now, how to calculate this V0? V0 you can calculate via this path. If I apply KVL in this path, you can start from this lower point 0 and you are going from minus to plus, so you just add 18. 0 plus 18 minus V0 will be equal to this point voltage, and this point voltage is 2V0. Okay, so you can write 3V0 is equal to 18 and V0 came out to be 6. So V0 is 6. If V0 is 6, you can put it here, it will become 12 by 5. 12 by 5. 12 by 5 means 2.4 ampere. 2.4 ampere is coming from this side. And what about this value? This value is 3.75. This is 3.75 ampere. Now you can add these two currents to calculate the Norton current. So if you are adding this, then you will get 6.15, I think, 6.15. But 6.15 is in 3 options. You can see that. So one option, only one option is eliminated. Still you have 3 options. Okay, you have 3 options. One option is eliminated. Bombay is eliminated. So first target was to calculate Norton current. I think you have understood how to calculate the Norton current. Now it's time for Norton resistance or Thevenin resistance, because you know that the Norton current, Norton resistance and Thevenin resistance are same. So how to calculate the Thevenin resistance between X and Y? Tell me guys. So first we have done for Norton current. Now I need to deactivate independent sources to calculate Thevenin resistance or Norton resistance. Okay. So what I do is I sort it here. I open it and I sort it. Okay. So the resultant circuit will look like this. We have this 1 ohm and the voltage across this is V0. It is sorted. And here you have the dependent source. Dependent source value is 2V0. Okay. And the current source is open. You have 5 ohm here. 5 ohm, and this is X, this is Y. This is 4 ohm, and you have deactivated this. Okay guys. So this is the circuit we have. Now tell me, if you look at this circuit carefully, then you can see that this and this are in parallel. And this voltage is V0 and this voltage is 2V0. And we know that in parallel, this voltage and this voltage has to be equal. This is V0 of this polarity and this is 2V0 and they are in parallel. We know that because they have the same end point and they have the same starting point. You can see that this branch and this branch are in parallel. So they must have equal voltage. How can these voltages be equal? There is only one way, and that way is if V0 is 0. If you take V0 to be 0, then you can see that this is 0, this is also 0. Okay, so V0 has to be 0. We found that. If V0 is 0, this voltage is deactivated. This voltage will become 0 volt. 0 volt means it is sorted now. Okay, so if V0 is 0, you can directly sort it. And if you can sort it, you can see that this 5 ohm and this 4 ohm, they will be in parallel. Okay, because this voltage is also 0. This will also be sorted. This is also sorted, this is also sorted. So there is no resistance on this side. Now you can see that from X to Y, there is 5 ohm and 4 ohm. What is the parallel of 5 and 4? So I have to take 5 into 4 divide by 9. 20 by 9. Okay. And 20 by 9 is 2.222. Answer is Agra. Okay. Answer is Agra. So this was a very good question. I hope you understood it. Tell me guys. So this was a simple question, and Actually, it was not that simple, but it was not that difficult also. Okay, so we have calculated that this Thevenin resistance came out to be 2.22. Now let's come to the next question, guys. The next question on your screen is, the switch in the figure has been open for long time. This is the switch and it is open for long time. Before it closes at t equal to 0. So we are closing the switch at t equal to 0. The current IT at time t after the switch is closed. So we need to find the equation for this current. What is the equation for this current? Tell me, guys, which option is correct? Think about it. Think about it. Which option is correct? Which option is correct? Do it fast. Let's see how many of you can solve it. Think about it, everyone. You don't need to completely solve the problem. You can use the options to find the correct answer. With the help of time constant, you can calculate, you can eliminate two options. And with the help of initial current in the inductor and initial value of this inductor current, with this IT is in the inductor current. Na? So initial value of the inductor current and the steady state value of the inductor current. Using that, you can check the correct answer. You don't need to write the complete equation. So tell me, guys, which option is correct? Do it fast. Do it fast. Let's see how many of you can solve it again. It's not difficult. It's not lengthy. And don't forget to like this session, everyone. We need a target of 30 likes. Okay. So please like it. This will be our Guru Dakshina. Okay. Do it fast, everyone. Do it fast. Ashok is saying Delhi. Okay. Let's wait for others. Tell me, guys, what is the correct answer? We know that first the switch was open. If the switch was open, this circuit was working for a long time. Okay, if this circuit was working for a long time before closing this switch, if this circuit was working for a long time, it means the inductor will behave like short circuit. So how much current will flow? 18 divided by 9, 2 ampere. It means at t equal to 0 plus, this I 0 plus has to be 2 ampere. Because if the switch was open, this current was 2 ampere. If you close the switch, this current will not change abruptly. This is the inductor current, and inductor does not change its current abruptly. It means at t equal to 0 plus, this current has to be at 2 ampere. Now check in which option it is 2 ampere. You can see that if you put t equal to 0, this will give you 2 value. This will give you t at t equal to 0, this will give you 2 again, and this will give you minus 2. So this is wrong. Okay, you can eliminate it. At t equal to 0, this will become minus 2. This current is not minus 2, this current is plus 2. At t equal to 0, this is also giving you 2 values. So it means one option is eliminated. At t equal to 0, we have calculated the current. Now switch is closed. Now let's say switch is closed. If you close the switch, after closing the switch again, after long time, again steady state will be achieved. Again steady state will be achieved after closing the switch. Okay, at t equal to infinity, because you are closing the switch at t equal to 0. So at t equal to infinity, again this circuit will come under steady state and inductor will be sorted again. So now tell me, what is the infinite current? What is the current at t equal to infinite? At t equal to infinite, again this is sorted. And which circuit will work? The circuit will be like this. This will be 18. This will be 18. This is 6. And it is 2ix. 3, and inductor is sorted. At t equal to infinity, this circuit will work. And what is Ix? Ix is this current. This downward current is Ix. Okay. This is my Ix. Inductor is sorted, and we need to calculate this current IT. At t equal to infinity, this circuit will work. Now can you calculate what is this value of this current IT? You can apply nodal. You can assume that this current is 0. This voltage is 0. If this voltage is 0, this voltage has to be 2Ix. This voltage has to be 2Ix. Okay. So you have found this 2ix. Now let's apply KVL in this path. If you apply KVL in this path, you will get 2ix minus 6ix. Wait. So you will get 2ix minus 6ix minus 18 equal to 0. So you'll get ix is equal to minus 18 divided by 4. So you'll get minus 9 by 2. Ix is minus 9 by 2. If ix is minus 9 by 2, what about this voltage? This voltage will become minus 9 volt. If this voltage is minus 9 volt, what is this current IT? Minus 9 minus 0 divided by 3. So this IT will become minus 3 ampere. It means I infinity has to be minus 3 ampere. Now in which option? At t equal to infinity, you are getting minus 3. At t equal to infinity, in this option, you are getting minus 3. In this option also, at t equal to infinity, you are getting minus 3. In this option, at t equal to infinity, you are getting plus 3. Eliminated. Okay. So at t equal to infinity, answer current is minus 3. Now there are two options. And you can see that the time constant is different in both the cases. Here the time constant is 4. Here the time constant is 0.25. What is time constant? Actually, you compare with this term, e to the power minus t by tau. So tau here is 1 by 4. That's why 4 will be in the numerator. Na? So tau here is 1 by 4 and here the tau is 4. Here the tau is 4. Okay. So now we need to calculate the time constant, and with the help of time constant, you can get the correct answer. Okay. So how to calculate time constant? It's very simple. What you can do is, we know that the time constant is L upon RTH. So L is 12 Henry. And what is RTH? RTH is the Thevenin resistance of this circuit after closing the switch. After closing the switch, what is the Thevenin resistance of this circuit? To calculate the Thevenin resistance of this circuit, you have to deactivate this. Okay, you have to deactivate this and then calculate the equivalent resistance of this circuit. What is the equivalent resistance of this circuit, guys? Can you tell me what is the equivalent resistance of this circuit? Tell me, what is the equivalent resistance? To calculate the equivalent resistance, so the circuit will look like this. This is 6 ohm. It is sorted because independent source, so I have sorted it. And this is 2ix. And this current is ix. And you have 3 ohm. And I need to calculate the equivalent resistance between these 2 points. Now you can see that if this current is ix, this voltage has to be 6ix. And this voltage are in parallel. And when the two voltages are in parallel, they must be equal. How can this 6ix and 2ix become equal? There is only one way, and that one way is ix has to be 0. If ix is 0, then you can say that this voltage and this voltage are equal. So if ix is 0, this voltage will become 0. It means it will become sorted. This will also become 0. It means it will also be sorted. So what is the equivalent resistance between these 2 points? That is 3. Okay. So RTH came out to be 3. So tau came out to be 4. We have calculated the time constant is 4. So if you put 4 here in the numerator, it will come out to be 0.25. It means answer is Agra. Okay. Answer is Agra. Tell me, guys. So there is no need to find the entire expression of the current. You can calculate the initial current, you can calculate the steady state current, and you can calculate the time constant. Okay. Using these three things, you can check the correct answer. Okay. I hope you got the point. This will make you fast. Okay. This will make you fast. Okay, guys. So let's come to the next question. Next question on your screen is this. Again, it is from network theory. The switch was in position 1 for long time. Okay. The switch was at position 1 for long time. And it is moved to position 2 at t equal to 0. At t equal to 0, we have moved to position 2. We need to calculate d square it by dt square at t equal to 0 plus. What is this value? E equal to 0, E equal to infinite and short circuit. Manasvi Agarwal. I'm not getting your point. What do you want to ask? E equal to 0, E equal to infinity and short circuit. I'm not getting your point. Okay, guys, let's try to solve this question. Please solve it. This is again a very good question. It's a very good question. Do it fast. Let's see how many of you can solve it. Do it fast, everyone. Do it fast, do it fast. It's again a simple question. We need to check for previous question. We need to check this for previous question. I'm not getting your point again. What do you need to check? At t equal to 0 plus, you are getting 2 ampere. At t equal to 0 plus, it is also short circuit. Why? Because the previous circuit was under steady state. Before t equal to 0, this circuit was working, and this circuit was working from minus infinite time. करोड़ों साल से काम कर रही है. It means this has to be short circuited. So the current has to be 18 divided by 9, 2 ampere. So initial current is 2 ampere. Because after closing the switch, this current has to be 2 ampere. It will keep the current same. Now after closing this, and then after t equal to infinity, again we have to check. After closing and after t equal to infinity, again it will be short circuited. And we need to calculate this I infinity. So you can sort it. Again you can sort it. After sorting, you just have to calculate this current IT. Using nodal, you can calculate, and this came out to be minus 3. Now I need to calculate the time constant. Time constant is L upon RTH. Thevenin resistance seen from these two terminals. So L is 12 and RTH you need to calculate. So to calculate RTH, you have to deactivate this independent source, and then you can calculate the Thevenin resistance. Okay. So I hope it is clear. Let's come to the next question, guys. Okay, in this question, I need to find d square IT by dt square at t equal to 0 plus. So we know that the switch was at this position for long time. What do you mean by long time? It means for infinite time this circuit was working. This circuit was working for infinite time. So it means this will be short circuited, because this circuit is working for past thousands of years. So you can say that this current has to be 10 divided by 1000, 1 by 100 ampere. This current has to be 1 by 100 ampere. Okay, and this voltage will be short circuited. This will be short circuited. Okay, and this current will be downward, and it will be 1 by 100 ampere. Now what you are doing is at t equal to 0 plus, you are moving this. It means you are changing the circuit. So if you are changing the circuit will look like this. At t equal to 0 plus, the circuit will look like this. It has some initial current now in downward direction. That is 100, and you have the capacitor. Okay, and this direction current is given as IT. This direction current is given as IT. Now, how to calculate d square IT by dt square at t equal to 0 plus. So we need to find this value. So what I can do is, I can apply KVL or KCL here to get this double derivative term. And we know that this initial voltage is 0. This capacitor is initially charged at 0 volt. We know that. So if you apply the KVL, in this path, then what you can do is, this is the current IT. Okay, remember this is the current IT, and the initial value of the IT is 1 by 100. Okay. Now what I can do is, let's apply the KVL in this path. If you apply KVL in this path, this is 1000. Okay, and this is 2 Henry. If you apply KVL in this path, because this current is moving like this, and if I apply the KVL in this path, it will become minus LdI by dt, because current is entering here. So wherever the current enters, that will be plus, and this will minus, this will be plus, this will be minus. So I am writing KVL at t equal to 0 plus. At t equal to 0 plus, I am writing the KVL. So it will be minus L dit by dt. This is the voltage across this inductor. Minus 1000 IT minus this VCT is equal to, this is the KVL equation, but we want to write it at t equal to 0 plus. So you can put t equal to 0 plus on both sides. So if you put t equal to 0 plus, you will get minus 2 di 0 plus by dt minus 100 minus 1000 I 0 plus minus VC 0 plus is 0. Capacitor voltage was 0, at t equal to 0 plus there was no voltage across the capacitor. So from here, and this value came out to be minus 1 by 100. Why minus 1 by 100? Because IT is in this direction and the initial current is in downward direction. So you can say that this I0 plus is minus 1 by 100. So you can put minus 1 by 100 here, it will become plus 10. Okay, this will become plus 10. So you can see that di0 plus by dt, take this 2 di0 plus by dt on this direction, so it will become plus. If you take this on the right hand side, it will become plus and this will become 10. Now you will get di0 plus by dt, that is equal to 5. So we got this value, but we don't want this. We don't want this. We want the double derivative term. How to get the double derivative term? How to get the double derivative? To get the double derivative, I have to take the derivative of this term. I have to take the derivative of this KVL equation. If I take the derivative of this KVL equation, then it will become minus 2 d square it by dt square minus 1000 dit by dt minus dvct by dt, and that is equal to 0. Okay, this is the expression. Now the interesting part is, we know that in this capacitor, after closing this point, this is the current IT. We know that this C dV by dt has to be equal to IT. We know that if IT current is moving like this, so the voltage, if you take the derivative of the voltage multiply by C, that has to be equal to IT. So what I can write is, I can say that dVct by dt is equal to IT by C. It has to be equal to IT by C. So I can replace this with IT by C. So if I replace this with IT by C, okay, let's replace it with IT by C. Let's replace this with IT by C. I hope it is clear. This is IT by C. And now you can put t equal to 0 plus on both sides. If you put t equal to 0 plus on both sides, then it will become minus 2 d square I0 plus by dt square minus 1000 into di0 plus by dt, and di0 plus by dt is 5 minus I0 plus by C. I0 plus is minus 1 by 100, so it will become plus 1 by 100 into C. C is 10 raised to power minus 6, and that is equal to 0. Now you can calculate this value, guys. How to calculate? You can write it like this: minus 2 d square I0 plus by dt square minus 5000 plus, what is this value, guys? This value will become 10 raised to power 4. So you can say that it is 10,000, and that is equal to 0. So this 10,000 minus 5,000 will become plus 5,000, and this plus 5,000 will go on this side. It will become minus 5,000, and you take this minus 2 in the denominator. So you will get, it will be 2,500. Is it clear, everyone? You will get 2,500. It will be positive, plus 2,500. Because if you take this plus 5,000 on this side, it will become minus 5,000, and minus minus will cancel. Okay, so you'll get plus 2,500. So this is the correct answer, guys. Plus 2,500. This was a very good question. I hope you understood it, and simple. Okay. So guys, don't forget to like this session. It's very important. This will be your Guru Dakshina. And let's move to the next question. Okay, I think this question is missing, which with reference to the equivalent circuit of the transistor shown in the given. Let me check the diagram and let me correct this question so that you can solve it. Okay, so now we have a question, and I think this is the last question of network theory. Yes, the diagram is given as 2 ohm 5 ohm J3 and this is the dependent voltage source 3I1. Wait a minute. No. I think a question is missing. Okay. This is the next question, guys. So excuse me for this question. Okay, this is missing. This question is missing. Okay, this question is missing. Let's come to the next question, guys. The next question on your screen is this. The Z parameter of the circuit shown below. Calculate the Z parameter. Which option is correct? Which option is correct? You don't need to apply the method to calculate the Z parameter. You can use the options also. With the help of option, you can calculate the correct answer. You don't need to solve it entirely. Don't waste your time. It will make you slow. So rather go with the options. Think which option is correct. So tell me, guys. It's a simple question. We need to find Z parameter. Tell me the correct answer. And don't forget to like this session. Everyone, those students who have not liked it, please give the Guru Dakshina. And Guru Dakshina is, you have to like this session. This is the only Guru Dakshina. Our target is 30 likes. So this is again a simple question, guys. Within 1 minute you can solve it. You know that this current is I1, this current is I2. So this current has to be I1 plus I2. And if you write KVL in this direction, in this loop, you can say that V1 is equal to 7 plus J3 I1 plus 5 plus J3 I2. If you write the KVL in this loop, you will get this equation. It means Z11 has to be 7 plus J3 and Z12 is 5 plus J3. So you can see that in A and C, Z11 is 7 plus J3 and Z12 is 5 plus J3. 5 plus J3 here, 7. It means you can eliminate these two options. You are now at 50%. You are now at 50%. Okay. Now you have to check for Z12 or Z21. Z21, Z22. For that you need to calculate. So how I can calculate Z2? So for that you can write the KVL in this loop. Okay. For that you can write the KVL in this loop. So what is the KVL in this loop? So V2 minus 3I1 minus 5 plus J3 into I1 plus I2 is equal to 0. This is the KVL in the second loop. Okay. So if you simplify this, V2 will be equal to, tell me guys, what is the coefficient of I1? The coefficient of I1 is 8 plus J3. It means Z21 is 8 plus J3. So answer is Agra. Answer is Agra. Okay. So this was a simple question. This was a simple question, guys. Okay. Let's come to the next. Obviously, it has I2 term also, but there is no need for I2 term, na? With the help of I1, we got the answer. Because two options were eliminated. Out of these two, we have to calculate Z21. So Z21, 8 plus J3. So only this option has 8 plus J3. That's why this is correct. Okay. You have to be fast, guys. Let's come to the next question. Next question is again, this is the last question from network theory, guys. Okay. This is the last question from network theory. Do it fast. Consider the following network. The value of ZL for maximum power transfer to it. We need to calculate what is the value of ZL so that the maximum power can be transferred to it. So this ZL has to be equal to ZTH conjugate. ZTH conjugate. Okay. So we need to calculate ZTH. And you can take the conjugate of that. That will be my ZL. Now tell me what is the correct answer. How to calculate ZTH? So we need to calculate ZTH for this question. We need to calculate ZTH for this question. Do it fast, everyone. Do it fast. To calculate ZTH, you can sort it. Now this is the circuit we have. We have sorted it. And you can assume that this is grounded. This is grounded. Okay. Now, what I need to do is, After sorting it, I need to calculate what is the equivalent impedance between these two terminals. So what you can do is you can apply a current source of 1 ampere, 1 angle 0, and calculate the voltage across this. Whatever the voltage across it will be, that divided by this 1 angle 0 will be my ZTH. Okay, and then you can take the conjugate to find the ZL. I think you can solve this question. Tell me which option is the correct answer, guys. Think about it. Tell me which option is the correct answer. Which option is correct? Tell me. So you need to calculate the Thevenin impedance. So what I have done is I have taken this 1 angle 0 and I want to calculate this voltage. So you can apply nodal, or what you can do is, so you can see that there are multiple junctions. This is one junction point, this is one junction point. So you can reduce this junction. Now you can apply source conversion here. So if you apply source conversion to reduce this problem, so it will become minus J1. Okay, and this is J1. Okay, and what I have done is on this side I have applied the source conversion, and this is V0. Okay, if you apply source conversion, this 2 ohm will be in series, because actually it was in parallel with the current source. So now this 2 ohm will come in series with a voltage source of 4 V0. This will become 2 into 2 V0, so it will become 4 V0. Okay, this way you can apply the source conversion. And we have applied 1 ampere here, 1 angle 0. And I need to calculate this voltage across this current source. This lower point at 0 volt. If somehow we can calculate this VA divided by 1 is my ZTH. Okay, VA divided by 1 is my ZTH. So this voltage I need to calculate. For that, what you can do is you can always apply the nodal. If you apply the nodal, what is the coefficient of VA? The coefficient of VA is 1 by J plus 1 by 2 minus J is equal to 1 angle 0, and this will be 4 V0 divided by 2 minus J. Okay, what is V0? V0 is this voltage. How to calculate this voltage? Tell me. The calculation of this voltage is very simple. Let's first calculate this current. This current will be VA minus 4 V0 divided by 2 minus J. This is the current. This current into this impedance minus J. This will be my minus V0 value. Why minus V0? Because this current multiplied by this impedance will be the voltage with this polarity. But V0 is of opposite polarity. That's why I have written minus V0. Okay. Now from here you can simplify and you can see that minus 2 minus J. So you can take this 2 minus J on this side into V0 will be equal to minus J into VA minus 4 V0. Okay, now you can calculate V0. This minus is gone, and take this V0 term on this side. So if you take this V0 term on this side, you will have V0 into 2 minus J, and here you have minus 4J. So it will become plus 4J. That will be equal to J into VA. So V0 came out to be, tell me guys, V0 came out to be J divided by 2 plus J3. 2 plus J3 into VA. Okay, so this is my V0. Now you can put this V0 here in terms of VA and take this VA on this side. So it will become VA 1 by J plus 1 by 2 minus J, and if you take this on this side, it will become minus 4 by 2 minus J into V0, and V0 is this value. V0 is J divided by 2 plus J3. Okay, and this is 1 angle 0. Okay, now from here you can calculate V0 value, sorry, VA value. You can calculate VA value, and whatever the VA is, the same will be my ZTH, because VA divided by 1 angle 0 is VA itself. So VA is my ZTH, and you have to take the conjugate of that, and you can calculate the correct answer. So I think the calculation is a bit lengthy, but you can solve it. Okay, so you have to tell in the comment section what is the correct answer. Okay, I have told you the process. which process you need to apply. Okay, so this way you can solve it. Now sometime this type of question will come in HAL also, so you have to be selective. Don't waste your time in these type of questions because it will take more time to solve. So you have to be very selective. You know how to solve it, so it's kind of you can say don't be greedy. Okay, don't think that. So there are so many questions which you can solve within 10 seconds or maybe within 30 seconds. So better solve those questions first and try to attempt this type of question at the, if you have some time, then you can attempt this type of question. Don't start with this question because this is a lengthy question, though it's simple, but it takes time. That's the main problem. Calculation takes the time. That's the main problem. So you can leave this type of problem, guys. But since we are not solving the exam, so we are just practicing it. So you can comment in the comment section what is the correct answer for this question. Okay, let's come to the next question. This is now we have started control system. Okay, now it's time for the control system, guys. So let's start this. The unit step response for unity positive feedback. Okay, so there is a positive feedback, guys, is given by this t into e to the power minus t and minus 2 e to the power minus t, or maybe plus. Let me check. Whether it is minus or plus. Okay, so it is plus 2 e to the power minus t. This is positive. Okay, so there is a positive feedback, and because of the step input, this is the response. So what you can do is you can calculate the transfer function, the closed loop transfer function. So closed loop transfer function will be, if you take the Laplace of this, ys over rs, cs over rs you can also write. So what is the Laplace of this? If you take the Laplace of this, it will become minus 1 by s plus 1 whole square. Okay, the Laplace of this function is, I think, this value. Okay, is it correct? Everyone tell me, is it correct? Because we know that e to the power minus, if you take t ut, what is the Laplace of this? It will be 1 over s square. If you multiply with minus t, it will become 1 over s plus 1 whole square. Okay, it will become s, you can replace s with s plus 1, and if you take minus here, you will get minus sign here. So this is the Laplace of this function plus 2 divided by s plus 1. So this is my ys or cs, you can say. If you take the LCM, you will get s plus 1 whole square. In the numerator, you will have 2 into s plus 1 minus 1. So you will get 2s plus 1 divided by s plus 1 whole square. This is my output Laplace. Okay, and the input Laplace is 1 by s. And obviously, you have ut along with that. Okay, so now tell me, guys, so you have this Laplace of output and Laplace of input as 1 by s. So what is the closed loop transfer function? Closed loop transfer function is output Laplace divided by input Laplace. So it will become 2s plus 1 into s divided by s plus 1 whole square. Okay, so we found the closed loop transfer function. But the closed loop transfer function is not asked. Which quantity is asked? We need to find the open loop transfer function. It means GS I need to calculate because feedback is unity, but it's a positive feedback. So this closed loop transfer function has to be equal to GS divided by 1 minus GS. Why? Because the feedback is positive. So you need to calculate this GS value. You need to calculate this GS value. How to calculate this GS value? It's very simple. What you can do is, you can write it like this: s into 2s plus 1 divided by, you can open it, s square plus 2s plus 1. Okay. Now what you can do is, you can take this common. You can take this common. So if I take this common, it will be s into 2s plus 1 divided by, I have taken this common, s square plus 2s. I have taken this as common. Or rather, there is one more way. In the numerator, you have 2s square plus s. Okay. In the numerator, you have 2s. So one way is very simple. You can cross multiply and calculate the GS value. Okay. Just cross multiply and calculate the GS value. Okay. Why to go for difficult method? Okay. But there is one more method by which you can compare and by which you can directly solve. What is that method? In the numerator, you have 2s square plus s divided by, in the denominator, you have s square plus 2s plus 1. Now, what I can do is, whatever term in the numerator is, the same should be in the denominator. How to make the same term in the denominator? How to make the same term in the denominator? What I can do is, I can add s square, or just don't do it, okay? Actually, I was experimenting, so let's not do it. Let's take the cross multiplication, okay? So just with the help of cross multiplication, you can solve for GS. If I cross multiply, you'll get GS into, tell me guys, s plus 1 whole square is equal to 1 minus GS into s into 2s plus 1. Now take this GS term on one side. If I take this GS term on one side, you will have s plus 1 whole square, and this is minus of GS into, so this GS coefficient will come on this side, it will become plus s into 2s plus 1, and on this side you have s into 2s plus 1, okay? Now from here you can calculate the GS value. Tell me what is the GS value. In the numerator you will have s into 2s plus 1, s into 2s plus 1, and in the denominator you have 3s square, because this is s na. So 2s square plus s square here, 3s square plus 3s square plus 3s plus 1, 3s square plus 3s plus 1. So answer is Agra, okay? Answer is Agra. So it's simple. You can directly solve like this, okay? We need to calculate the open loop transfer function. So we have calculated the closed loop transfer function, and then we know that in positive feedback it has to be GS divided by 1 minus GS. You can calculate the GS from here and check the correct answer. Let's come to the next question, guys. The next question on your screen is impulse response of a unity feedback system. So because of delta t, the response is e to the power minus 4t sine 2t ut. Okay, this is the response. Steady state error due to unit step input. Steady state error due to unit step input I need to calculate. So, can I calculate transfer function from here? The transfer function is output Laplace divided by input Laplace. So, if I take the output Laplace, you will get 2 divided by s plus 4 square plus 4, okay? So, this is the output Laplace and the input Laplace is 1. So, we have calculated the closed loop transfer function. Now, we have this system. This is GS and there is unity feedback. I need to calculate the steady state error. Now, how to calculate the steady state error? We know that this is RS and this is YS. So, this signal will be ES and ES will be equal to RS minus YS. This is my ES. Take this RS common. It will be 1 minus TS. This is my ES. But we want the steady state value. We want ET steady state. So you can apply the final value theorem. You can multiply it with SRS into 1 minus TS. Limit S tends to 0. Okay. TS we know that this is my TS. And RS is 1 by S. Because for unit step input I need to calculate the steady state error. So RS is 1 by S. So this is gone. So the steady state error is 1 minus limit t tends to infinity, limit s tends to infinity, s tends to 0, ts. Okay. Now in this expression, if you put s tends to 0, it will become 2 divided by 16 plus 4. So it will become 2 by 20. 2 by 20 is, tell me, 2 by 20 is 1 by 10. So 1 minus 1 by 10, 0.9. Okay, so the answer is 0.9. Answer is Calcutta. Okay, so this was again a simple question and I hope you all have solved it. Okay, so guys, let's move to the next question. The next question on your screen is this. Please solve this question. It's an easy question. This is based on sensitivity. Do it fast, everyone. We need to calculate the sensitivity of closed loop transfer function with respect to A. We need to calculate this. Tell me what is the answer for this question. We need to calculate the sensitivity of closed loop transfer function with respect to A. Do it fast, everyone. It's a simple question. Do it fast. It's a simple question. Do it fast. So what is the expression? I think this is correct. Okay. So what is TS? Let's first calculate the TS value. Closed loop transfer function TS. So closed loop transfer function TS is K divided by S plus K plus A. This is my closed loop transfer function. Now I need to take the derivative with respect to A. So what is the derivative of this with respect to A? So if I calculate dt divided by dA, then it will become S plus K plus A. Take the square of that. In the numerator, you will have S plus K plus A into 0. So this is gone. Okay. Minus K into derivative of this denominator term with respect to A. So the derivative of this denominator term with respect to A is 1. Okay. So it is minus K divided by S plus K plus A whole square. This is the derivative of this term. Now into A divided by TS. TS is this. In the denominator you have K and here you will have S plus K plus A. Okay. Now you can see that this 1 power is gone. Okay. This 1 power is gone and K is also gone, and it is given that A is 1, omega is 0 and K is 1. Omega 0 means S is 0. So S is given as 0. A is given as 1. So you can put 1 here and 1 here, and K is also 1. So you can see that in the denominator you have 2. In the numerator you have 1 and there is minus sign out. Okay. So tell me guys, so the answer is minus 1 by 2. This was a simple question. Let's come to the next question guys. So the next question is on your screen. The asymptotic Bode plot of the transfer function is this is the asymptotic Bode plot. Okay. It is given to us. The magnitude of error in dB gain at the frequency omega equal to 2 radian per second. Now he want to know at omega equal to root 2 what is the error. Error means this is the asymptotic Bode plot with respect to the actual Bode plot. What is the error at this omega equal to root 2? At omega equal to root 2 in asymptotic Bode plot it's 20 dB. Height is 20 dB. What is the height of actual system at omega equal to root 2? So what you can do is in this expression I can put omega equal to root 2 first. So if I put omega equal to root 2, it will become 20 divided by, if I put s equal to j omega, it will become minus omega square plus j2 omega, okay, plus 2. Okay. So I have put s equal to j omega and omega is root 2. You can put omega is root 2, so it will become 2 divided by, so this will cancel, no? Okay. So 20 divided by j 2 root 2. And if you take the magnitude, it will become 10 by root 2. 10 by root 2. This is the actual magnitude at omega equal to root 2, but we want the magnitude in dB. So if you want to calculate this in dB, it will become 20 log 10 minus 20 log root 2. And 20 log 10 is 20 dB minus 20 log root 2. What does it mean? It means this is the actual height at omega equal to root 2. And in asymptotic Bode plot, the height is 20 dB. So what is the difference? This is the difference. We call it 3 dB. This value came out to be 3 dB. So the error is 3 dB. Error is 3 dB. It's simple. Okay. This question was simple. So now we are coming to the last question. Okay. And try to solve this last question guys. So we have open loop transfer function of unity feedback system 10 divided by s plus 2 raised to the power 4. Then the gain margin of the system. What is the gain margin? try to solve it, and let me connect with Rakesh Talreja sir, because from this question onwards Rakesh Talreja sir will continue. So let me contact him and let me ask sir whether he is available or not. Okay, so guys, don't forget to like this session, because our target was 30 likes and only 26 likes are there. Okay, so I want you to like this session. Everyone, please like it. Okay, now let me ask Rakesh sir. Okay guys, Rakesh sir is ready. So let's try to solve this question. Now you can see that the open loop transfer function, it means GSHS is given to us. And remember, the gain margin will always be calculated from open loop transfer function, 10 divided by S plus 2 to the power 4. This is our GSHS. What I need to do is I need to find the gain margin of the system in decibel. How to calculate the gain margin? We know that to calculate the gain margin, we need to find omega PC, phase crossover frequency. Because if you plot its polar plot, if you draw its polar diagram, then we know that if I replace S with j omega, then it has some magnitude, it has some phase. What is the phase? The phase is -4 tan inverse of omega by 2. Okay, this is the phase of this function. And if omega tends to infinity, this angle will go to -360. Okay, so if you start with omega equal to 0, then it will start from 2.5 and it will go like this. It will go like this. So this will be the polar plot of this diagram. Now we call this frequency as omega PC, phase crossover frequency. Phase crossover frequency is the frequency where this phase has become -180. Okay, this is omega PC. Now let's calculate omega PC. Take this -4 on this side, so you will get tan inverse of omega by 2 will be equal to, tell me what is this value? It came out to be 45. Okay, came out to be 45. It means omega has to be 2. So at omega equal to 2, the phase is -180. The phase of this function is -180. It means this is my omega PC. Now at omega PC, you can calculate this magnitude. We call this magnitude as A. And the gain margin is 20 log 1 by A. You know that. Okay. So what is this magnitude A? We know that if you replace S equal to j omega, it will become 10 divided by j omega plus 2 raised to the power 4. Okay. This is our GSHS. Now what I need to do is I need to calculate its magnitude at omega equal to 2. So you can put omega equal to 2 here, and I need to find its magnitude. What is the magnitude of this function? So let's calculate the magnitude. Magnitude will be 10 divided by, the magnitude of this function is 2 root 2 and raised to the power 4. Okay, this is the magnitude of this function. So it will become 10 divided by 2 to the power 4. 2 to the power 4 is 16 into root 2 to the power 4. It will become 4. So this is the magnitude we have. It means this will become A. So what I can do is I can put this A value here. So it will become 20 log 1 by this value. So it will become 64 by 10. This much of dB. Okay. Now you can calculate this value. Tell me guys, what is this value? So this is an easy question. This is an easy question. We can easily calculate the gain margin in decibel. Okay. So I hope you understood it, and you can solve this answer. You can calculate this value. Okay. So guys, I think it's time to take rest, because from this point onward, Rakesh sir will continue, and there will be a glitch of 1 or 2 seconds, maybe more than 2 seconds. It will maybe glitch of maybe 4 or 5 seconds. So just wait for that, and from now on Rakesh sir will continue. Okay, so let me talk to Rakesh sir and let me stop the streaming so that he can join.
Hi guys, a very good morning everyone. Welcome to the HAL mini mock, and let's continue. Already have been discussing some questions and now time to move on towards another questions. You are done with 23 questions, I believe. All right. Okay, so I shall continue now. Very good morning everyone. Keep joining. ठीक है चलिए. All right, so let's get moving ahead guys, and these are the different subjects we are covering in this HAL mini mock. Saket sir completed EMFT, then Ashu sir has covered network theory and control system. I'll be moving towards the questions from digital circuits and signal and system, and then Sanjay Rathi sir will be joining for analog circuits. So let's get moving ahead guys quickly, and here it is, the next question for you. Just a second guys. अच्छा नहीं, वहां से ये नहीं चल रहा ना, ठीक है. चलो गाइस, या आप जब तक मैं मैनेज करता हूँ. Okay, yeah, sorry for the interruption. So let's get moving ahead guys. This is that question number 24. Let's get started with digital, and then we will move on towards the question from signals. One by one we will do it up. Okay, so consider the arithmetic operation performed in a particular number system whose radix is equal to r. So there is this number system with base r or radix r. Okay, and there is a mathematical arithmetic operation given to you. Okay, 23 plus 44 plus 14 plus 32 in base r is equal to 223. What should be the value of the base? Okay, let's get started. So purely on the HAL level, what could be the expected type where I'm going to cover up? I'm going to cover up. तो ये ले लीजिए guys, 23r, okay, plus 44r plus 14r plus 32r. Okay. Now what should this be equal to? Now this is position 0 and position 1. Okay, so 2r power 1 plus 3r power 0. Don't write out r power 0. So 2r plus 3. Okay. Next is simply 4r plus 4. Similarly, next will be 1 into r, that is r plus 4. नहीं हो रहा, इसमें देखते हैं. पर आप ट्राई कीजिए. चलो ठीक है, मैनेज करते हैं. ठीक है गाइस, या सो प्लस r plus 4, and next what it is? Okay, 3 into r, that is 3r, and then plus 2. Okay, 3r plus 2. Okay, now this was in the entire left hand side. So if I just calculate 6 and 7, this is I think 10r. Okay, and then 7, 11, 13, 10r plus 13. Okay, now what is this? This is 223r, and this is again position 0, 1, 2. So this should be 2r square plus 2 into r plus 3r power 0. Okay, so now just you have to equate this. So what you have, 10r plus 3. Okay, I've converted both to decimal actually, and that should be equal to 2r square plus 2r plus 3, or 2r square minus 8r, and 3 is cancelled, I think. Am I correct? Sorry, this is 13, so it's not cancelled. And then minus 10 is equal to 0. 2 को cancel किया तो r square minus 4r minus 5 equal to 0. Clearly factorize as, this is factorized as r minus of 5 and then r plus of 1 equal to 0. So what is the value of r? It is 5 and minus 1. The base cannot be negative. The base cannot be negative here. So r equal to 5. Okay, what is the radix of the number system? It is equal to 5. Yes, Ashwar, Ashok, Prince, very correct answer. It is the option number A. Yes, it is the option number A. Correct, Ji. Yeah, it is the option number A. Done. Let's move ahead to the next one. Okay. So what is the next one I have? It is, look into this. Which gate is redundant in the following circuit? Which gate is redundant, which can be reduced? Okay, उसके होने नहीं होने से फर्क नहीं पड़ेगा. Which is one of those gates? Which is one of those gates? Okay, so let's solve it up. Let's just solve the circuit here only. This is the output of inverter W bar, and the same W bar goes here and gets ANDed with Z. So this is W bar Z. And what do you have here is XY multiplied by Z bar. Okay, X, Y, Z bar. So what is the final output F? The final output F is like, first one is W bar, next is W bar Z, next is X, Y, Z bar. By looking into this equation, you should be able to understand there is some elimination. Okay, there is some elimination. Right. Yes, Ashok, very few PYQs you can find on internet because it is all memory based. I'm working out with some students. So if I get a good database, definitely will provide to you. Chalo. So now what is happening here? Guys, W bar is common and 1 plus Z is reduced. 1 plus Z is equal to 1. Okay, so what is the value of F is now W bar plus X, Y, Z bar. And you're able to see that this entire term W bar Z is no longer needed. So which gate is redundant? Okay, the W bar Z, this particular term, which is the output of gate number 2, this is redundant. This is redundant. Correct. It is redundant. Okay. Yes, Prince, Manasvi. Not the Z bar gate. Not that Z bar gate. That is not. The second gate is redundant, Manasvi. Okay. Chalo, done hai. Jyotsana, check it out. Not the first one. Okay, W bar plus W bar Z to W bar is left. Now W bar is not reduced. Okay, so gate number 2 is reduced actually. Gate number 2 is reduced. Done hai? Next question, number 26. Okay, a 4x1 mux is used to implement a 3-input Boolean function as shown in the figure. The Boolean function implemented is, what is the Boolean function that is implemented? What is the Boolean function that is implemented? Okay, so now it's a simple multiplexer based question. Let us write down select line 0, 0. 0, 0 means B bar, C bar, and at 0, 0, I naught is selected. I naught is directly connected to A, right? Plus select line 0, 1, right? Plus select line 1, 0. 1, 0 means BC bar. Plus select line 1, 1, that is BC. Okay, now 0, 1. 0, 1 pe I1 will come, and what is I1? I1 is equal to A bar actually. At the select line 1, 0, I2 input is selected and I2 is 1. Logic level 1, and select line 1, 1, I3 is selected, but I3 is like 0, grounded. Okay, that is grounded. Now we just have to reduce it and arrange it in the form of F, A, B, C, because A is the MSB here in the given representation. So A, B bar, C, sorry, A bar nahi hai. This is equal to A, B bar, C bar, plus A bar, B bar, C, plus B, C bar. The last term is 0. Okay, last term is 0. Okay, now this can further be made now. Okay, this can further, if you want to write down in the minterm form, so what you can do here is, you can add A and A bar here. Well, you can add A plus A bar. Okay, so that A plus A bar is 1 and ultimately the term is not affected. So this can be written as A, B bar, C bar, A bar, B bar, C. Okay, plus A bar, B, C bar, plus A, B, C bar. Okay, so for BC bar, I add A plus A bar and then I separate it out. So what are the minterms coming up? 1, 0, 0, 4. Right. 0, 0, 1, 1. 0, 1, 0, 2. 1, 1, 0, 6. Arrange in the increasing order 1, 2, 4, 6. And option is 1, 2, 4, 6. Option is A. Arranging in the increasing order. Yes, Ashwar, correct answer. Okay, it is going to be A. Right there. It is going to be A. Chalo, done hai. We're done. Next one. Moving ahead to the next one, number 27. Number 27. The CMOS circuit shown below implements what function? The CMOS circuit shown below implements what function? Okay, implements what function? Dekh lete hain. The CMOS circuit implements what function? Now, see, the one method is you can make the truth table and solve the CMOS circuit, or else you can try to recall, the basic functionality of NAND and NOR that you study in the CMOS circuit. Okay, so if you go by that particular logic now, okay, look into these two. Okay, A and B in parallel in this NMOS case. So it will be representing A plus B. Okay, and then that is completely, okay, multiplied by C because it is in series. Okay, then this whole network till ground is connected in parallel with D. Okay, so I'm able to write it out. And similar approach you should follow, especially for HAL type exams, because you have limited time. You can solve again by making truth table, but you applied that series and parallel logic at least for the simple circuits. Okay, so as I told you, I can write it as A plus B, and then it should be whole multiplied by C, and then this whole circuit in parallel with D. Okay, so I'll write it as D, and then whole complement of it. And then the whole complement of it. Okay, so it's option number C. It is the option number C. Right, Ji? It is option number C. No, Prince, it is C. Just check out once. Okay, it's not going to be AB, na? It's not going to be AB. A plus B. A plus B. Yeah, Ashwar, correct answer C. All right, guys. Good one. The correct answer is C. Moving ahead to the next one. Okay. Number 28. An SRAM has address lines from A0 to A19 and data width from D0 to D15. Okay. The total capacity of the SRAM. So these are very common and very much expected questions, especially in these small time examinations and government examination. Chaliye. Okay. It has the address lines from A0 to A19. So total 20 address lines. Okay. So how many addresses? What is the logic of solving these questions? Number of addresses is equal to 2 raised to the power 20. Right, because there are 20 address line and every bit can be 0 or 1. Okay, and then, okay, at every address, the data bus is D0 to D15. That means one data is 16 bit. Okay, one data is 16 bit. Okay, so data capacity is 16 bits per address. Okay, so total size 2 power 20 and every address can store 16 bits. Right, this will now be broken as 2 power 20 into 2, right, into 8 bits, and 8 bits is bytes and options are in bytes only. So this is 2 raised to the power 21. Acha, 2 power 21 ko, dekho, what is 2 power 20 actually? 2 power 20 is 2 power 10 whole square, right, and 2 power 10 we know is 1k. 2 power 10 is 1024, but 1024 we call it as 1k. That is the nearest value to the 1000 in binary number system. Okay, so this becomes 1k into 1k, 1m, this is 1m, and then this is 2, and this is 1 byte. 8 bits is 1 byte. So ultimately it is 2 MB. It is the 2 MB, option number A. It is a 2 MB. Manas, we just recheck the calculation. It is 2 MB. Done. Okay. Okay. Why whole complement, Manasvi? See, when you study the basic CMOS, yeah, even NMOS, PMOS logic, okay, what is this functionality equal to? If this is A, this is B, right, and you derive the output from here, and on the above side, you will draw the complementary PMOS circuit. So this turns out to be NAND gate, na A into B, but whole bar. See, I told you, one method is drawing the truth table for the given circuit. But if you recall your basic fundamentals of series and parallel gates in the fundamental CMOS logic family, so this is not AND gate, now this is NAND gate, A into B, whole bar. Okay, now why it is whole bar, that you have to again go and study the CMOS. Okay, so if I cover that, a lot of time will go. Okay, I'm just covering the questions here. But that is a hint I've given to you. ठीक है जी, so it is 2 MB, not 16. Okay, 16 megabits hota hai. You know, in this terminology, in this terminology, we know that. Okay, B means the byte, not the bit. So don't be confused. It is not 16 megabytes. 16 megabits will be there. Okay, agar bits ke form mein likhna hai, to yeah, definitely. Okay, there will be 16. This is megabits, but MB means bytes, megabytes. Okay, so correct answer is A. The correct answer is A. Next one, question number 29. Which one of the following must be the initial value of shift register such that Q3, Q2, Q1, Q0 is 1001 after the first clock edge? So what is the result after first clock edge that is given to me? What is the result after the first clock edge that is given to me? It is moving on its own. Just a second. Right. So after first clock pulse, the result is given to me. Okay, that is 1001. So let me write down what is Q3, Q2, Q1, Q0, what should be the initial value, right, and what should be the serial input. Okay, ये भी देखना पड़ेगा. Such that after the first clock pulse, I have 1, 0, 0, 1. Now we know that clearly it is a right shift register, and because it is the right shift register, it is very clear that these three last bits in the previous clock should be occurring here. Should be occurring here. So 0, 0, 1. Okay, then only it will right shift, it will right shift, it will right shift. Okay. So whatever it is, it should start with 0, 0, 1. That is option A or B. What about the Q0? वही decide करना है ना? Okay, and that we will decide by taking the idea from serial input. Now this is 1. Okay, if this MSB is 1, so the serial input should be 1. Then only the MSB becomes 1 after sliding in. Okay. Now, what is the value of the serial input, dear? What is the value of the serial input? Now, how the serial input is derived? It is XOR of, okay. It is the XOR of Q3 and Q2 and Q0. It is the 3 input XOR. Okay, 2 XOR gates are cascaded, so we can call it as 3 XOR. Okay, and this serial input is required to be 1. That means XOR of Q3. Now, what is the Q3? Q3 I know 0. Q2 is also 0, dear. Okay, and Q0 is missing. What is missing? The Q0 is missing. The Q0 is missing, but the XOR of these 3 bits is 1 and 3 input XOR. Okay. The XOR gate output is high whenever the input string contains odd number of 1s. Okay, so that is only possible if you have a 1 here. If you take Q0 equal to 0, so you will not have odd number of 1s, and how the output can be high? So output of XOR is high, so odd number of 1s, so Q0 will be equal to 1. Okay, Q0 will be equal to 1. So आ गया 0, 0, 1, 1. 0, 0, 1, 1. ठीक है जी. Now Aishwar, it's not A, it's going to be B. 0, 0, 1, 1. You have to decide with that Q0, and that is coming out to be 1. That is coming out to be 1. Right है जी. चलो बढ़िया. Okay. Fundamental yet good questions, but less time consuming, so definitely HAL type. ठीक है. But yeah, it's a decent question. Moving ahead to the next. All right. Okay, so moving ahead to the next. These were the 6 questions from digital, and now I have 6 questions from signals for you. Okay. The fundamental frequency of the signal, a discrete time simple periodic signal is given to you. Yeah, if it may be aperiodic also, that also is an option available. You can comment. Okay. So cos pi by 4n. Cos pi by 4n. Right. What is 2 pi by omega? Here is 8. Okay, and because 2 pi by omega is directly an integer, that is a time period. Because in discrete time, you have to be careful. Na? In discrete time, the period is not always, 2 pi by omega. Okay, it's not always directly the 2 pi by omega. Yeah, but the signal is periodic if 2 pi by omega is a rational number. Okay, and the period is always an integer. That's what you have to be careful about. So 2 pi upon pi by 4, that is equal to 8. Okay, here 2 pi upon pi by 8, omega is pi by 8. So this is 16. This is also integer. So directly this is the period. So let's say this is the time period N1. Let's say this is the time period N2. Okay, now what is the final time period? Now what is the final time period? Okay, so N1 upon N2, if I simplify it, it is 8 by 16, or in the simplified ratio, it is 1:2. So final time period is given by cross multiplication, that is 2i's of N1, or that is also equal to 1 times N2. जो भी लेना है. Twice of N1, or that is equal to N2. Or that is equal to N2. Right, what is the twice of N1? Okay, 16, yeah, N2 16, anything. The answer is C. It is 16. The answer is 16. Done hai? They are asking the fundamental then options match nahi hoga. Sorry guys, it should be the fundamental period. Okay, let me correct the question. Otherwise options then will not match. Okay, write down the fundamental period. Okay, write down the fundamental period. Okay, there is a correction in the question. The fundamental period. Chaliye, next one. Let's move to the next question. Number 31. Consider a signal Vt with the Fourier transform Vf. If V dash f represents the Fourier transform of V to t, what is the relation of V dash f to Vf? Very simple property based question, because if Vt has the Fourier transform Vf, of Vf, okay, then V to t, time scaling, has the Fourier transform 1 upon modulus of A, that is 1 upon 2, V of f by 2. That is the Fourier transform. And this is what is V dash f. Okay, they have called V dash f as this part. What is V dash f? 1 by 2 V of f by 2. Definitely the amplitude is scaled by half, that is 0.5. Okay, and Vf by 2, whether it is compression or expansion in frequency domain, bandwidth की बात कर रहे हैं ना, so whether it is compression or expansion, V of f by 2, the factor is 1 by 2 with f that is multiplied, so that represents expansion. Okay, for less than 1 it is expansion, for greater than 1 it is compression. Okay, so it is bandwidth expansion along with the magnitude scaling by 0.5, option number B. Magnitude scaled by 0.5, bandwidth expanded. Bandwidth expanded. ठीक है जी? Next question. Consider the signals x1t and x2t as shown below. Which of the following statements are true? Which of the following statements are true? Okay. Very, very clear. Very simple question here. It is the property based but very much expected. Don't it? Okay. The given signal x1t. Okay. It is real as well as even. It is even symmetric. Agar x1t की बात करें, so we are able to see that okay, it is real or it's on the real plane only, real axis. It's real and even, right? So what is going to be the Fourier transform? It's Fourier transform x1 omega. That will also be real and even. Okay, the spectrum of x1t will be real and even. This is correct. Coming to x2t, x2t is again a real signal, but showing what? Showing what? The right hand side, okay, is negative of the mirror image of left hand side, right? Okay, so because when you take the mirror image of left side, it will come out to be here +1, but it is -1. So they differ only in sign. They differ only in sign. x2 minus t is equal to minus of x2t, right? So it is real and odd. When the signal is real and odd, its Fourier transform, is pure imaginary and odd. Okay, so spectrum of x2t will be imaginary and odd. So which of the statements? Now, if it was a gate mein this can be 1 mark MSQ question. In the gate, it can be 1 mark MSQ question. Out of the 4 options, 2 will be correct. But this is HAL MCQ pattern is there. So that is why 4 options have been created. Out of which we can select the option number C. Only an S2 and S3. Only S2 and S3. That is the option number C. Okay? Yes, Ashwar and Manasvi. Correct answer. Prince, एक बार just recheck कर लीजिए. S2 and S3. Signal is real and odd, but the spectrum Prince will be pure imaginary and odd. The Fourier transform is pure imaginary and odd. ठीक है, next चलते हैं. Okay, number 33. Consider the following cascade of 2 subsystems with the impulse responses h1t is equal to minus of h2t is 1 upon pi t. Okay, that means h1t 1 upon pi t. What is the Fourier transform for 1 upon pi t, dear? Fourier transform for 1 upon pi t minus j signum omega. You can recall it from the Hilbert transformer concept as well. See, we can find out, but this result is important because it is, the Hilbert it comes under the Hilbert transformer result. Okay, so minus j signum omega. Okay, now what is h2t? ध्यान देना, minus h2t is 1 by pi t, so h2t is minus 1 by pi t. Okay, so when you calculate its Fourier transform h2 omega, that will be minus actually plus j signum omega. Plus j signum omega. Now, 2 systems are cascaded. Okay, they are in cascade. Okay, so when 2 systems are cascaded, the impulse response is convoluted. Okay, and when there is convolution in time, there is multiplication in the frequency domain. So what is the overall, right? Suppose the overall impulse response is h1t convolution h2t. So overall frequency response will become h1 omega multiplied by the h2 omega. So one of them is minus j signum omega. Another one is equal to the j signum omega. So minus of j square, that will become plus 1 actually, because j square is minus 1. Signum omega into signum omega, that is signum omega square. Now what should be signum omega square? Nana Prince, S4 is not correct. That's what I explained you. S4 is not correct. Right. S4, how it is correct? Spectrum of x2t is not real and odd, na? Signal is real and odd, but its spectrum will be pure imaginary and odd. Prince. Okay, it is 100% false. Chalo. आ जाते हैं. हाँ. What is the signum omega square, dear? What do you think? What is the signum omega square? What is the signum omega square? Without drawing, you should be able to calculate in mind. Now, what is the signum omega square? It is +1 on the right hand side. It is -1 on the left hand side. But eventually, when you square it up, 1 square or -1 square, okay, it's going to be 1. Signum omega square is going to be 1. Signum omega square is going to be 1. Okay? Right. Now, what is the step response of the overall system? What is the step response of the overall system? Okay, step response means the response when the response, suppose that is equal to yt, when the input applied is unit step. Okay, what is the yt? Yt is given by the input convolution with the impulse response. What is the input? Step input. That is ut. Convolution with ht. What is the ht? Dear, what is the ht? But the h omega, the overall frequency response is 1. That means ht is whose Fourier transform is 1? Whose Fourier transform is 1? Delta t, na? Whose Fourier transform is 1? Unit impulse. Okay, so ht is equal to delta t, and whenever you convolute any signal with delta t, okay, the same signal will be obtained. The convolution of a signal with unit impulse signal will replicate the signal, so it is going to be ut. Right, it is going to be ut. Okay, so final answer is also a step function only. The final output is also a step function only. Done it? The final answer is step function. Correct answer is B. Okay, ji. Correct answer is B. Next question, number 34. A discrete time, linear time invariant system with input xn and output yn is characterized by yn is equal to 0.1 xn plus 0.9 yn minus 1. If two such systems are connected in series, again sort of cascaded question here, which of the following is the governing difference equation? Okay, is the governing difference equation. First of all, पहले इस difference equation को simplify करते हैं, right? And if you solve in terms of difference equation, it will be lengthy, right? Okay. Question number 33. Oh, great. So guys, see, the Don is here. Okay, the champion, the Don from civil engineering. And see guys, even Abhinav sir from civil, he has solved the step function question. It is the option number B. Great. Welcome to the session, sir. चलिए guys, आ जाते हैं. तो yn is equal to 0.1 xn plus 0.9 yn minus 1. If you solve in the difference equation, it is going to be lengthy, but try to convert into the z transform. When you take the z transform, yn z transform is suppose yz. Yn z transform is suppose yz, and that is equal to 0.1 xn z transform suppose xz. And now apply the time shift property. What should be the z transform for yn minus 1? Yz into z inverse. Okay, so if I collect the terms of yz on the left side, 1 minus 0.9 z inverse, and then I am in a position to write down the transfer function of the system. What is the transfer function of the system? It is the ratio of output to the input z transform, and that is 0.1 is divided by 1 minus 0.9 z inverse. 0.1 is divided by 1 minus 0.9 z inverse. Right? ठीक है जी. Okay, now if two such systems are connected in series, but both are similar system, this has the transfer function hz, this also has the transfer function hz, and when two systems are connected in series, if you solve in time domain, then the impulse response are convoluted, right? If you solve in the case of transfer function, so we know that the gains will be multiplied. Okay, so what is the overall? Okay, it is simply hz into hz. It is going to be hz multiplied by hz. Okay, yeah, isko h1 h2 bol do, but ultimately it is same, and that is going to be my overall transfer function. Okay, that is 0.1 upon 1 minus 0.9 z inverse. The another one is also the same, so isko square kiya, so 0.01 upon, just apply a minus b whole square, so 1 minus 1.8 z inverse, calculation check karte jana. Okay, plus b square, so that should be 0.81 z power minus 2, and this is the overall transfer function, which is the overall output by input. And now you can again convert to the difference equation. Okay, you can again convert to the difference equation. So when you convert to the difference equation, okay, you will have yz minus 1.8 z inverse yz plus 0.81 z power minus 2 into yz. is equal to 0.01 of xz. Done hai ji? Okay, now convert back to the time domain. This is yn. Z inverse means one right shift, yn minus 1. Then you have 0.81 y of n minus 2, because z power minus 2 is for second time shift, and this is 0.01 xn. What is the correct option that is going to match here? Okay, yn, yeah, here it is, option number A directly. Yn minus 1.8 yn minus 1 plus 0.81 yn minus 2 is 0.01 xn. 0.01 xn. ठीक है. अच्छा, अब आप ये देखो, फॉर यू आई विल ऑलवेज गिव द कंप्लीट सोल्यूशन फॉर योर अंडरस्टैंडिंग. ठीक है, बट एज सून एज यू राइट अप टू दिस स्टेप यू शुड बी एबल टू मैच द ऑप्शन ना. आप तो यहां पे मैच कर सकते हो, राइट? 1 means this is directly going to be yn. Z inverse, one right shift. Z power minus 2, okay, second right shift property will come up. Okay, so directly, you know, even if you realize this denominator, you are able to match the options, right? Chalo, done hai. Next one. Option match kar diya tha? Yeah, A is the option. Next one, and this is the sixth and last question of signals. Okay, and let me parallelly also give a call to Sanjay Rathi sir. He'll be ready after this. He'll be ready after this. Just a moment. Consider an 8-point sequence xn given to you. Let xk be the DFT. What is the value of xk at k equal to 4? Hello? Sir, ready है? Last question है. ठीक है, मैं आपको कॉल करता हूँ. हाँ जी. Okay, so let xk be its DFT. What is the value of xk at k equal to 4? Right, at k equal to, it's a 8-point sequence. So this is like the midpoint n by 2. Right, very important. Not only even for HAL, this is simple question, but you will find that even in the GATE exam, okay, the questions based on x0 and xn by 2. Okay, yeah, uske around, they make good questions sometimes for 2 marks as well, for sometimes 2 marks as well. Always remember the very two important results. If I want to talk about x0, it is directly given by the summation xn. By the DFT formulas, we can derive it up. Okay, summation n equal to 0 say n minus 1, that is summation for all values of n xn. And then when you talk about the central ordinate property x of n by 2, it is given by summation n equal to 0 say n minus 1 xn, yeah, minus 1 power n xn. Now, when you open the first one, it is summation of xn for all values. That means it is x0 plus x1 plus x2, etc. But this one is minus 1 power n, and we know minus 1 power n will alternate in sign. Minus 1 power even is positive, minus 1 power odd is negative, right? So this is going to be x of 0 minus x of 1 plus x of 2 minus x of 3 plus minus up to the length. ठीक है जी? So what is the answer here then? What is the answer here then? Okay, so here x of 4, that is x of n by 2, will be equal to, just take minus j, then next one will be minus. Okay, plus of this, then minus of this, then plus of 0. Okay, then minus of 2. Okay, then plus of minus 3, then minus of 0, then plus of 0, then minus of 1. This should be my final answer. This should be my final answer. So definitely minus j plus j cancelled. Minus 5, minus 1, minus 6. Minus 6. एक लाइन में सॉल्व होगा क्वेश्चन, ऑप्शन नंबर बी. Very useful properties. X of 0 and x of n by 2. Even in some questions of GATE, you will see that if you solve without this property, the question looks lengthy. You will find lengthy solution many places, but if you recall these properties, many questions of GATE also look simple, right? DFT, important topic, especially for GATE, it is very important topic. HAL may be question expected, iska, HAL, ISRO, everywhere, but for GATE, it is definitely a 2-marker producing area, especially for EC as well, right? And if you want the complete clarity of DFT, okay, I have already taken one marathon on the DFT, discrete Fourier transform. There is around 2.5 to 3 hours marathon completely. It's long back I took, but still it is sufficient. Okay, all properties, all type of questions, techniques, theory, everything is there. Okay, so whenever you feel that you want to learn DFT, because it is very important topic, there's a 2.5 hour to 3 hours, exact time I don't remember, but a complete marathon to give you complete details. You can watch it up. You can search by my name. I took some time back, but it is available on the channel. You can search it by my name. Okay, dear. So correct answer is option number B. That is minus 6. Yes, Ashok, the very correct answer. Okay, now guys, so what I've covered for you is, I have covered 6 questions from digital and 6 questions from signals in this mini mock. Okay, and now Sanjay Rathi sir will join us and he'll be adding to the questions of analog circuits. Okay, so just stay tuned. So stop कर दूं?
Hello everyone, very good afternoon and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Now this is Sanjay Rathi and I'm going to start with analog questions. So thank you Rakesh sir, and now we will discuss 10 important questions from what analog. So let me know that sound quality, picture quality, everything is fine. Yes please. Yes please. Okay, I think now everything is fine. Okay guys, now this is a HAL 2023 mini mock test. I hope that your preparation is going well guys. Okay, so Ashok, Mansvi, Nandesh, everyone, first of all like the session and share the link of this session and subscribe our channel, because we are going to start one important series for you. Okay, so that is now today evening at 7:30 p.m. I'm going to take very important session for you, that is the how to use mock test effectively and efficiently. So mock test analysis, weak and strong points and revision. So what is this cycle? I'm going to explain. Okay. Then second important thing, it is a, please note the time, that 7:30 p.m. evening, today evening. Okay. Then we are going to start ISC Bangalore previous year question series 2002, 2008 and 2016. तो आपको भी पता है this year that GATE exam is conducted by what? Organized by IISc Bangalore. तो कैसा है पेपर का पैटर्न ये पता चलेगा जब आप प्रीवियस ईयर क्वेश्चन सॉल्व करेंगे. तो वी विल सॉल्व प्रीवियस ईयर क्वेश्चंस ऑफ this year and that year for electrical, electronics and what? Computer science branch. And so that I am saying that please subscribe the channel. Okay, so Nandesh, fine. Mansvi, now ready to solve some questions and quickly try to solve this question because it is HAL exam. We can't use what? Calculator. So give me the answer for these questions. Now this is the first question from what? Operational amplifier. From operational amplifier, that is the first question. So tell me the input resistance of the circuit shown in the figure, assuming an ideal operational amplifier, is very simple. Input resistance. What is the input resistance of this particular circuit? So try to give me the answer for this one. Then I am just giving you the hint that if this is the operational amplifier, ideal operational amplifier, then in normal circuit this is called inverting operational amplifier. This is zero virtual short concept, and if the Vi is connected here, then this R1 is called input resistance. This R1 is called input resistance because the input resistance is equal to Vi upon I1. That is the current given by this battery. So that is the answer R1. But what is the answer for this question? What is the answer for this question? R is connected here, 3R is connected here, 2R is connected here. And this is a simple inverting operational amplifier and the input resistance is R1. But what is the input resistance for this particular circuit? Okay. Now I am going to give you, okay, what is the answer? Everyone please participate in the comments and try to solve this question. 1 minute. Okay, I think everything is fine now. Okay then. Now, how to solve this question? First of all, convert this. You can convert this delta into what? Star. So this is the first point, this is the second point, and that is the third one. Let this is the Rx, this is the Ry, and this is Rz. So when the delta is connected into star, this is what Rx. Rx is equal to R into 2R upon summation of R plus 2R plus 3R, and you will get 2 by 6, that is R by 3. R by 3. Similarly, what is the RY? This is the RY. This register, which registers are connected? R and 3R. R into 3R, denominator will remain same, 6R, that is become R by 2. Then RZ, 2R into 3R, 2R into 3R, denominator will remain same, 6R, that will become R by 6. Now, you can convert this into what? Star. Then what is the circuit then? What will be the circuit? Now, watch this. If you are going to convert, already we have find the value of Rx, Ry and Rz. Then you can redraw the diagram. This is Rx. This is connected to Vin. What is Rx? R by 3. This is Ry. This is connected from this point to what? Towards the ground. Towards what? This point. Then now third register that is connected here is 3R. This is the Ry. What is the value of the Rz? What is the value of the Rz? R by 6. And this Ry is equal to what? R by 2. So delta is connected into what? Converted into star. Now we have the R in is equal to, this is virtual short concept, this is 0, this is 0. What is the R in? C into the V in? R by 3. R by 3. So that answer is what? R by 3. Okay, Ashok, now it is clear, everyone? So this is the answer for this question, R by 3. Is there is any other method to solve this question? Yes, there is one other method because calculator is not allowed. Now watch this. You can solve the same question by using Miller's theorem. By using what? Miller's theorem. So you will get the idea about the Miller's theorem. So how quickly we can solve this by using the Miller's theorem? Now watch this. Now first of all, to apply the Miller's theorem, there is a resistor 2R here. There is a resistor 2R between V0 and Vi. So what is the V0 by Vi? Let this is the K, V0 upon Vi. That is called gain of the system. Now what is the gain of the system? Virtual short concept, this is 0, this is 0. You can apply the KCL at this point, 0 minus Vi upon R plus 0 minus V0 upon 3R. V0 upon 3R is equal to 0. From this you will get V0 upon Vi is equal to 3 minus 3. Check. This is called gain of the system from V0 upon Vi. So here V0 by Vi we are also getting this, right? Divided and you will get. Now this is the V0 upon Vi. Then guys, what we can do when we are applying the Miller's theorem? When we are applying the Miller's theorem, you can break this resistor. When we are breaking this resistor, then 1 minute. Now watch this. By applying the Miller's theorem, this resistor is R, this resistor is, by using the Miller's theorem, you can break R upon what? 1 minus K. R upon 1 minus K, and here this will remain 3R, and we have break this resistor. So this resistor break means this is connected here. What is the value? 2R upon 1 minus K. We have break this resistor, and we have the ratio of V0 upon Vi. Then one resistor here, KR upon K minus 1. KR upon K minus 1. And what is the value of the K? Minus 3. So minus 3 means what? This will become 2R upon 1 plus 3, minus minus plus, and it will become R by 2. Now, this voltage is 0. This voltage is 0. So up to this point, what is the input resistance? R. Up to this point, what is the input resistance? R parallel with R by 2. R parallel with R by 2. That is nothing but R into R by 2 upon R plus R by 2. And you will get R by 3. You will get again R by 3. So that is what Miller's theorem. So there are two ways to solve this question. One way is what? Apply the star delta, right? And but put the proper value there. Put the proper values, right? What are the values? R by 3. But we want what? R by 3. That is what is the input resistance for the given circuit, guys. Okay. I think now it is clear, everyone. This question is clear to you. This is clear to you. And star delta connection, no doubt, we have find a connection, but always remember what is the proper connection here, because where we are going to apply the star, what are the 3 points here? So there are the 3 points. Always remember for delta, there are the 3 points. This is the A point, this is the B point, and that is the C point, and that is the neutral point. So we have connected properly, right? So this is what B point. So we have to connect here properly. That connection is, that is what A to what? A to N. We are connecting, then N to B. RY is connected. This is the B point. And then N to C. RZ is connected. थोड़ा सा connection बस यहाँ पर ध्यान दे दीजिएगा. Yes. Now, this is the N, this is the B point. We are connecting this one, and that is connected to what? Output side. But ultimately what we want? We want what? This resistance. That is the input resistance, guys. Now, next question. So this is the, by using the Miller's theorem, you will get the idea about that. Second one. This second question is on 555 timer. So this, remember, 555 timer, again it is important for what? HAL. Then tell me what is the answer for this. This is 30 kilo ohm resistor. This is 10 kilo ohm resistor. This is a capacitor. This point is connected to 6 volt. This point is connected to pin number 2. This point is connected to pin number 6. 8 supply is 9 volt, and 8 normally when it is not in use, it should be connected to reset pin. 4 number pin is the reset pin. Now a name is given here. Now tell me, a stable multivibrator circuit using 555 timer is shown below. Assume that the circuit is oscillating. The voltage VC across the capacitor varies between. Any idea, Mansi, what is the answer, Nandesh, for this question? The voltage VC across the capacitor varies between. So when, always remember, if it is a astable multivibrator, what we are doing, we have some standard answer for this. So what is the standard answer for the diagram? Now, okay. This is the standard circuit for a stable multivibrator. This is ground. This is supply. This is connected to reset pin. And here RA, RB, and what? C. Now this C is connected to what? 6 and 2. And this is connected to discharge pin. This is 1, and from 3 we are getting the output. And the pin number 5, that is called control voltage pin, this is bypassed through a capacitor 0.01 microfarad. That is called a stable multivibrator. Here the voltage across the capacitor is connected to what? 2 and 6. When the voltage across the capacitor is connected to 2 and 6, then the range of the voltage across the capacitor is VCC by 3, this is the minimum value, to what? 2 VCC by 3. This is the maximum value. VCC by 3 to 2 VCC by 3. So number of students, they will apply the general formula. VCC is what? 9. So they will apply 9 by 3 to what? 2 into 9 by 3. And what is the answer? 3 to 6 volt. 3 to 6 volt. But that answer is what? 3 to 6 volt B. B is wrong answer. B is wrong answer for this question. Why wrong? Because pin number 2 is connected to the voltage across the capacitor. But pin number 6 is connected. VC is not connected to pin number 6. Pin number 6 is connected here to this voltage. When any pin number, any voltage, for example, this voltage is connected to pin number 2, its lowest value is fixed. What is the lowest value? VCC by 3. But what is the highest value when particular point is connected to 6 number? Its highest value is fixed. What is the highest value of the VS? 2 VCC by 3. The lowest value will remain 3. But what is the highest value of VC? First of all, find the highest value of Vx. So we can find the highest value of Vx. That is about the 555 timer. What is the highest value of Vx? VCC by 3. 2 times of VCC by 3. That will become 6 volt. Okay. But what is asked in question? What is the maximum value of VC? So when this voltage is 6 volt, this resistor is 30 kilo ohm, this resistor is 10 kilo ohm, this voltage is 9 volt because it is 9 volt. And what is the highest value at this point? 6 volt. What is the voltage at this point when it is 6 volt? Then you can find the current. 9 minus 6 upon 30. What is the current? 3 by 30, that is 1 by 10. 1 by 10 milliampere. So what is the drop across this resistor? 1 by 10 into 10. 1 volt drop. And what is the voltage at this point? 6 minus 1. So what is the voltage at this point? 5 volt. So for this particular question, the range of the voltage across VC is not 3 to 6, not the standard answer. It is what? 3 to 5. It is, what is the time period of that? 0.69 RA plus 2 RB into C. And reciprocal of this will give you the frequency. And guys, get the formula for duty cycle also. Duty cycle for this particular diagram. Okay. So these are the standard formula. Next question. Any doubt? This is clear to you? Second one, 555 timer. That answer is 3 to 5. Now, third question. Again, calculator not allowed. The use of a rectifier filter in a capacitor circuit given satisfactory performance only when the load. तो जरूरत ही नहीं है कैलकुलेटर की, आपके ऐसे ही क्वेश्चन बन जाएंगे. बस ये आपको बताना है use of rectifier filter in a capacitor circuit given satisfactory performance. If it is a half wave rectifier, this is the diode, this is RL, this is without filter. This is without filter, half wave rectifier. Now what we are doing, we are connecting a capacitor in front of this, then it is called half wave rectifier with C filter. Half wave rectifier with C filter. For proper performance of this circuit or satisfactory performance of this circuit, time constant should be high. RLC should be very, very high. So that capacitor will not discharge and it will hold the value, constant value, that is Vm. And we are getting the output nearly equal to Vm constant, and that is the VDC is nearly equal to what? Vm. And what is the use of rectifier? We want to convert the AC signal into what? DC signal. So that is the Vm. Now, if RL is very, very high, then what about the load current? Load current will be low. So current is nothing but V0 upon RL. And this should be very, very low. Why? Because the RL should be very, very high. So in a concept, what will happen if this current is very low? So what is the discharging rate of the capacitor? Negligible. If the current is very high, then the capacitor will suddenly discharge. And we don't want to discharge the capacitor. We want that capacitor should hold that value, that is what? Vm, and output will remain constant. So what is the answer for this question? Current is low. The use of rectifier filter in a capacitor circuit given satisfactory performance. This is the keyword. Current should be low, right? So current should be low and voltage is constant. So this is a half wave rectifier with C filter. So what are the important, please revise formula for the rectifier, right, ripple factor, form factor, crest factor, efficiency, transformer utilization factor. In number of sessions, I have given the complete table of the half wave rectifier, full wave rectifier, bridge rectifier, half wave rectifier with C filter, full wave rectifier with C filter. Okay then. Now next one. The effect of current shunt feedback in an amplifier. Now this is the question from feedback. Now these days in gate examination we are not getting the question from this topic, but again this is important for what? HAL exam. Tell me, what is the current shunt feedback? अरे बताइए, which answer is correct? A, B, C, D. Current shunt feedback means what we are sampling at the output and what we are mixing at the current word. If the current word is used here, at the output we are sampling what current? We are sampling current actually. Current is the first word, means we are sampling the current here. This is the I naught, this is the I naught, and this is the RL. Now, shunt connection. So connection at the input is shunt connection, means we are mixing current. We are what we are doing? Mixing the current here. This is called shunt connection at the input. This is IS and this is the IF, feedback current. So at the output we are sampling the current, at the input we are mixing the current, and that's why it is basically a current amplifier, and that is the beta. So IF is equal to beta times of I naught. So what is the unit of the beta? IF upon I naught, unitless quantity. So what is asked in the question? Increase in the input resistance, decrease in the output resistance, increase both in input and output, decrease both input and output, decrease input and output. Now which answer? You are giving the C answer, okay? Guys, at the input side connection is shunt connection. When at the input side the connection is shunt connection, what about the input resistance? What about the input resistance? Decreases. When two resistors are connected in parallel, it is decreases. So input resistance will decrease, because this will come parallel to that. In output side it is a series connection, because it is a current sampling. Current sampling means series connection. In a series the current will remain same. So series connection means what about the output resistance? Increases. So increase input resistance, decreases the input resistance and increases the output resistance. Which answer is correct? D for Delhi. D for Delhi. Okay. Okay then, is it clear? This is, so please, there are 4 feedback mechanism: voltage series, voltage shunt, current series, current shunt. Okay, so please get the idea about that. What is the sampling? What about the what is the effect on the input and output resistance? For example, in this case, which gain will stabilize? Current gain, because basic amplifier is current amplifier. Output current, input current, and what is the stabilized gain? AIF is equal to I naught upon IS is equal to AI upon 1 plus beta AI. Normally this term is very greater than 1, and that is nearly equal to what? 1 by beta, and that is called stabilized gain of the circuit. Okay then, next question. भाई जवाब दीजिए, एग्जाम में ज्यादा डेट नहीं है. This is on what? September, right? 9th of September. We are not having the much time to revise all the topics from the analog, right? From what? Diode, application of the diode, up to what? All the applications of the operational amplifier. Now, and power amplifier is also in the course. The thermal runaway will take place if the quotient point is such that. What do you mean by the thermal runaway, everyone? What do you mean by the thermal runaway? That is the thermal runaway. First of all, IC increases. Because of IC, temperature increases. Once the temperature increases, ICO increases, and when ICO increases, IC is equal to beta IB plus 1 plus beta times of ICO. IC increases, temperature increases, ICO increases, and finally IC again increases, and that is called what? Self-destruction of the transistor, because finally the current will become too high and it may damage the transistor. So that is called self-destruction. Self-destruction of transistor. अच्छा चलो बताओ, आपने भस्मासुर का नाम सुना है? भस्मासुर एक राक्षस था, उसका नाम आपने सुना है ना? अरे भस्मासुर जिसको वरदान दिया गया था, वो जिसके भी हाथ में रखेगा वो भस्म हो जाएगा। तो अल्टीमेटली उसने अपने ही सर पे हाथ रख लिया और भस्म हो गया। दैट इज कॉल्ड सेल्फ डिस्ट्रक्शन ऑफ द ट्रांजिस्टर। तो दैट इज द सेल्फ डिस्ट्रक्शन, खुद ही भस्म हो गया ये, ठीक है, ट्रांजिस्टर है ये। एंड दैट इज देन हाउ वी कैन अवॉइड दिस सिचुएशन। हाउ वी कैन अवॉइड दिस सिचुएशन? सिंपली आपको क्या करना है, जो वीसी है, जो क्वेश्चन पॉइंट है, उसको हाफ ऑफ वीसीसी से कम रखना है। अगर इसको अवॉइड करना है तो इट शुड बी लेस देन और इक्वल टू व्हाट? वीसीसी बाई 2। ये है टू अवॉइड द थर्मल रन अवे। लेकिन आपको क्वेश्चन ना केयरफुली पढ़ना है। व्हाट इज, सब स्टूडेंट्स विल गिव द आंसर, सर डी इज द आंसर, डी इज द आंसर, बट व्हाट इज रिटन हियर? थर्मल रन अवे विल टेक प्लेस। अवॉइड नहीं करना है, विल टेक प्लेस। व्हाट इज द कंडीशन? व्हेन द वीसी इज ग्रेटर देन वीसीसी बाई 2। ए आंसर फॉर दिस क्वेश्चन इज व्हाट? ए। तो read question carefully and give the answer, otherwise you are going to do the silly mistakes in the exam hall. तो आराम से बनाओ, आराम से बनाइए, कोई हड़बड़ी नहीं है। पेपर निकालना है, एक्यूरेसी, ट्राई टू मेंटेन द एक्यूरेसी, एंड साथ में स्पीड भी मेंटेन कीजिएगा। ऐसा नहीं कि एक्यूरेसी मेंटेन कर रहे हो आप, आधे पेपर में बाहर आ जाओगे फिर तो, राइट? तो ये हुआ मॉक टेस्ट, एंड ट्राई टू गिव एज मैनी मॉक टेस्ट एज पॉसिबल। और अभी देखिए 15 अगस्त फिर एक मॉक टेस्ट लेकर आ रहे हैं हम आप लोगों के लिए, गेट एग्जाम के लिए। तो इंडिपेंडेंस डे में अपनी इंडिपेंडेंस के साथ टेस्ट दीजिए, ठीक है? ओके देन नेक्स्ट वन। अब देखिए, दिस इज द क्वेश्चन फ्रॉम मल्टी स्टेज एम्पलीफायर। व्हाट इज द क्वेश्चन फ्रॉम द मल्टी स्टेज एम्पलीफायर? अ ट्रांजिस्टर आरसी कपल्ड एम्पलीफायर, आरसी कपल्ड एम्पलीफायर। व्हाट इज आरसी कपल्ड? रीड द क्वेश्चन, एवरीवन रीड क्वेश्चन carefully. Just I am giving you the what is the RC coupled amplifier. This is the RC coupled amplifier. Here we are using the bypass capacitor, that is called C. Here we are using the coupling capacitor, that is called CC2. This is the VCC. Here we are giving the potential divider biasing. और ये देखिए, ये हो गया CC1. Right, here we are connecting, yes, right, okay then. इस सर्किट को देख के ऐसा नहीं लगता है कि जैसे हमारे जो भगवान होते हैं ना, उनके एक हाथ में त्रिशूल है, एक हाथ में ये है, सब कुछ अस्त्र शस्त्र लेके ये तैयार बैठे हुए। तो देखो, ये हमारे लिए भगवान ही है। हमारा सब्जेक्ट है एनालॉग, एंड बिकॉज ऑफ एनालॉग यू कैन मेक योर करियर इन व्हाट? VLSI और इन अदर फील्ड्स, इट डिजिटल एनालॉग। इसको देख के आप देखो ऐसा ही लगेगा, यहां देखो एक अस्त्र, यहां एक शस्त्र, एक यहां पर, एक यहां, एक यहां, अरे बहुत सारे कंपोनेंट्स हैं यहां, और सभी यूजफुल है ना, सभी यूजफुल है। तो ऐसे ऐसे सोच के पढ़ो, इसको इंटरेस्ट आएगा आपको, राइट? नाउ टेल मी, ट्रांजिस्टर आरसी कपल्ड एम्पलीफायर इज डिजाइन फॉर AV इज इक्वल टू 20. व्हेन वी आर टॉकिंग अबाउट द AV गाइस, AV, व्हाट इज द AV? AV is what? Mid band voltage gain. Because we have to set, but the measurement at a particular frequency shows that the gain to be only 14. Here we have set for 20 and we are getting only 14. ये तो बहुत ही ज्यादा गड़बड़ है, क्या हो गया यहाँ पर? तो what is the likely phase shift at this frequency? तो चलिए देखते हैं जरा क्या है ये RC phase shift oscillator. Now remember, these are called coupling capacitor, this is called bypass capacitor. At the same time, we are having the internal capacitance. Why? Because one junction is forward bias, one junction is reverse bias. One junction is forward bias, one junction is reverse bias in active region. When this particular emitter junction is forward bias, it has the diffusion capacitance. And when this junction is reverse bias, it has what? Transition capacitance, diffusion and transition capacitance. So we are having the number of capacitance, some internal, some external, right? So these are the externals, this is the internal, and they all are useful. Now, how we can solve this question then? Remember, what is the frequency response of this diagram? This is the frequency response of this diagram. And anyone give me the answer here? You are not giving the answer. What is the answer for this question? I am waiting for your response. This is the frequency response of RC coupled amplifier. This is the gain and that is the frequency. Now at the mid band, what is the gain? 20. But at a particular frequency, the gain is what? 14. Means gain decreases. Why the gain decreases? Tell me. Why the gain decreases? This is the gain 14. This is called higher cutoff frequency. This is called lower cutoff frequency. FL, FH. Now at the lower frequency side, this the gain is 14. This is the LED, the gain is 14. Now and mid band, this is called mid band area. Mid band. This is called high frequency region and this is called low frequency region. So we are doing the experiment at the high frequency side or the low frequency side. So why the gain decreases at the high frequency side? Because of the internal capacitance. And why at this side? Because of the coupling capacitor CC1, CC2, CZ or bypass capacitor. Now, so we are doing experiment at FL or what? We are doing the experiment at FH. Now remember, at the mid band, its phase shift is 180 degree. At the mid band, its phase shift is 180 degree because it is a common emitter. When we are increasing the frequency, at a high frequency side, it acts as what? Low pass filter. It acts as a low pass filter. And what is the low pass filter? It is a lagging circuit. Lagging circuit. And that's why phase decreases and at the cutoff frequency it will become 135 degree. At the low frequency side it acts as high pass filter. What is the high pass filter? This is the high pass filter. At this side the phase increases. So at this exactly at cutoff frequency the phase is 225 degree. So my dear friend, and this at the cutoff frequency the gain is what? 70% of what? Maximum gain. So what is the 14? 14 is nothing but 20 by root 2. You can check. 14. This is nearly equal to 14. The frequency at which the gain will become 1 by root 2 times its maximum gain, then that frequency is called cutoff frequency. So here it is a 14. Means we are, according to the statement, actually we are doing the measurement at lower frequency or at higher cutoff frequency. At that point we are getting the gain 14 only, that is the 70% of maximum. And at that frequency what will be the phase shift, likely phase shift? 225 or 135? So which is given in the answer? 135. 135 is the answer. Okay, तो भाई इतना एग्जाम में टाइम थोड़ी लगाना है, विद इन 10 seconds में बताना है आपको इसका क्वेश्चन. बट with the explanation of this question I have clear what? More than 100 questions. More than 100 questions we have cleared. Yes or no? Here in this diagram now you will get number of questions. So I have cleared 100 questions. So watch this: lower cutoff frequency, higher cutoff frequency, mid band voltage gain, what is the phase shift at this point, what is the phase shift at this point, it has the act as high pass filter, at this point it will act as what? Low pass filter. तो देखिए भाई मेयरली मॉक टेस्ट नहीं है ये, मॉक टेस्ट के साथ आपका नॉलेज भी इनहांस होगा. तो सब्सक्राइब कर लीजिए चैनल, क्योंकि अब बहुत सारे सेशन आप लोगों के लिए आने वाले हैं. ओके देन नेक्स्ट वन. Now that is the question on what standard circuit, guys. Very standard circuit. Use of the operational amplifier as what? Multi-vibrator. And this is a symmetrical circuit. What is written here? For the operational amplifier circuit shown, the output saturation voltage are 15 and minus 15. Here it is the 15, here it is the minus 15. These are called supply voltage. The upper and lower threshold voltage for the circuit are respectively. Tell me what is the name of the circuit. Name of the circuit is not given in this, but remember it is a bistable multivibrator. Bistable multivibrator, and that is nothing but symmetrical. Symmetrical. Okay. Now it is symmetrical, then 10 kilo ohm, 5 kilo ohm, 3 volt V out. It is a basic diagram of symmetric trigger circuit. Basic diagram, right? Not much explanation is required. So what is the answer for this one? This is R1, this is R2, this is called VR. What are the upper threshold and lower threshold? Upper threshold is given by plus V set into R2 upon R1 plus R2, R2 upon R1 plus R2 plus VR R1 upon R1 plus R2. So what is this? 15 into 5 upon 10 plus 5 plus 3 into 10 upon 10 plus 5. Okay, now you can find 15 into 5 upon 15, that is cancel out, plus 3 into 10 upon 15, 2, 3 cancel, and you will get the answer is what? 7. 7 volt is the upper threshold. 7 volt is the upper threshold. Now 7, where we have the upper threshold 7 volt? In only in one answer. So which answer is correct? B. So why in exam hall no need to find the second answer? No need to find. Why you are wasting your time? देखो ना, किसमें अपर थ्रेशोल्ड 7 है बताओ, तो एक ही आंसर है जिसमें 7 है और वो है बी. तो भाई क्यों बनाना इस क्वेश्चन को, सीधा बी करो, टिक करो, आगे बढ़ो, हो गया क्वेश्चन खत्म. Now if you want to solve the lower threshold, then remember what is the lower threshold voltage. Simply the everything will remain same. Everything will remain same. You have to use what? Minus sign here. You have to use the minus sign here, minus V set, negative supply. Then it will become minus 15 into 5 upon 15 plus what is the VR? 3 into 10 upon 15. And then it will become, this is what? Minus 5 plus 2. And what is the answer? Minus 3. Minus 3 volt. Is there is any need to verify it? Everyone tell me. In exam hall. Now here I will solve, but in exam hall, once you will get the upper threshold, no need to find the lower threshold. First of all, watch the answer, because we have to save every second. Every second is important, right? We can solve 10 more questions. Okay, then next. Then this is the diagram on what? BJT. This is the diagram on what? BJT. Consider the NPN transistor circuit shown below. Where is the NPN? Okay, this is the NPN. This is the NPN transistor. One is connected here, one is connected here, one is connected here. 1 mega ohm resistance, that is too high resistance, no problem. Now this voltage is what? VB. Bolege, sir, VB is not given in the question. My dear friend, VB is not given in the question means what? In a BJT, normally we are using the silicon transistor, and for silicon transistor, what is the VB? What is the value of VBE? 0.7 volt. 0.7 volt for silicon. So this is the 0.7 volt. By default we can take HFE, that is nothing but beta, it is given. You have to find the V0. So how we can find the V0? Very simple. Then watch this. If you want to find the V0 in this question, then you can apply what? KCL here. KCL, yes, we can apply the KCL. This current is what? IC. This current, what is the voltage at this point? That is the V0. Let this current is IL, because this is RL. And let we are having one current here. Any current, that is what? Let IZ. I. Can we apply the KCL at this point? Or let this is the, we can say that this is the downward current I. Now, what is the incoming current I? Is equal to outgoing current IC plus IL. IC plus IL. So what is the incoming current? 12 minus V0 by 2. 12 minus V0 by 2 is equal to IC plus IL. What is the IL? V0 minus 0 by RL. V0 by 4. Okay. From this you can find the V0. But what is the value of, IC? First of all, find the IB. 0.7. So IB will become, remember, IB will become 5 minus 0.7 upon, always convert it is in kilo ohm. So what is it? It is in kilo ohm, 10 to the power 3 kilo ohm. Resistor should be in kilo ohm, current should be in milliampere. 10 to the power 3, so it will become 4.3 into 10 to the power minus 3 milliampere. This is the value of the base current. So what is the value of the collector current? IC is equal to beta times of IB. You can neglect the reverse saturation current. Beta is 100. So 100 into 4.3 into 10 raised to power minus 3, you will get the answer 0.43 milliampere. 0.43 milliampere is the value of the current IC. Now, what is the value of V0? So now you can put, this is the 6, okay, sorry. Then you can put here, that will become 6 minus V0 by 2 is equal to 0.43 plus V0 by 4. 6 minus 0.43 is equal to V0 by 2 plus V0 by 4, 3 by 4 V0. Now tell me, what is the V0 is equal to? 4 by 3 multiplied with the difference. 6.43, that is a 4 by 3. And you will get around 7.5. You will get around 7.5 is the answer for this question. This is the answer. Nearly equal to 7.5. So guys, this is the VC. This is nothing but VC. If the VC is V0 is equal to 7.5, it is greater than what? 0.2 volt. Means our assumptions is correct. And transistor is in what? Active region. Because we have used this formula. And this is valid for active region only. Active region only. Remember. So finally we have verified this, that the BJT is in active region and we are applying the KCL at this point. Now, next one, I think no doubt in this question. अच्छा चलिए बताइए इनमें से कितने क्वेश्चन को आप बना सकते थे अगर आपको टाइम दिया जाता तो सोचो जरा. नेक्स्ट क्वेश्चन है, इट इज ऑन मॉसफेट. तो बस 2 क्वेश्चन और इंतजार कीजिए. ये 44th एंड देन 45th क्वेश्चन. वेट फॉर लास्ट क्वेश्चन. फॉर द n channel MOS transistor shown in the figure, the threshold voltage is 0.8 volt. Neglect the channel length modulation effect, means lambda is equal to 0. When the drain voltage VD is 1.6. Remember, when the drain is connected to gate, so VDS is equal to what? VGS. So VDS is equal to VGS means what? VDS is greater than what? VGS minus VT. Simple. VDS is greater than means it is in saturation. This is in saturation. And VDS is nothing but VGS, and VD and VG are equal and S is connected to ground. That means VD is nothing but VGS. VD is nothing but VGS. Now, in this case, you can apply the formula ID is equal to half of K and S W by L VGS minus VT the whole square. Everything is constant, therefore you can write K times of VGS minus VT the whole square, because this is everything is constant. In first case and second case, what is given? In first case it is given VD is 1.6, VTH is 0.8 volt, then the current is 0.5. You can write 0.5 is equal to K times of VD is nothing but VGS. VD is nothing but VGS. 1.6 it is given. VT is given as 0.8 the whole square. Now, second case. When VD is adjusted to be 2 volt, means we are increasing the value of the VD, means we are increasing the value of VGS. We are increasing the value of VD means we are increasing the value of VGS by adjusting the VDD and R. It will become 2 volt. When it will become 2 volt, VGS will become 2 volt. So what is the value of ID in second case? K will remain K. What is the new value? 2. Threshold voltage will remain same divided by 2. Now you can use 2 formula. Find the value of K from this, use here. Or you can divide these 2 equations. When we are dividing these 2 equations, 2 divided by 1, you will get ID 2 divided by 0.5. That is equal to K cancel. And it will become 2 minus 0.8 means 1.2 upon 1.6 minus 0.8. It will become 0.8 square of this. ID2 multiply this and you will get the answer. ID2 is equal to, okay. So that is the ID2. ID2 is equal to This is the 1 by 2, 0.5 means what? 1 by 2 into 1.2 divided by 0.8, 1.44 divided by 0.6. Okay, so you will get 1.125. 1.125 as the answer for this one. 1.125. Okay, now next one. Next question. ये हो गया सीधा MOSFET पर. Now last one from Zener diode, voltage regulator. Always remember, this is again in every exam, voltage regulator is very important topic. So I have covered the question from all the topics. MOSFET, BJT, Zener diode, application of the diodes, operational amplifier. Now it is a Zener diode. Now tell me what is the answer. The Zener diode in the regulator circuit shown in the figure has a Zener voltage of 5.8 volt. Zener breakdown voltage is 5.8 volt. And a Zener knee current of 0.5 milliampere, IZK. Knee current 0.5 milliampere. Maximum load current drawn from its circuit. Maximum load current drawn from this circuit. Right? This is the keyword. Ensuring the proper functioning over the input voltage range between 20 to 30 volt. Ensuring the proper circuit, proper operation or proper functioning over this range 20 to 30. Now what is the meaning of this keyword? Proper functioning means it is a voltage regulator. For 20 to 30 volt, output voltage should remain constant. Means Zener diode should remain in what? Breakdown region. Once the Zener diode it is in breakdown region, then Zener diode it is in breakdown region. Suppose you are connecting the RL here. You are connecting RL here. Now there will be the current IL. There will be the current I. And Zener diode current IZ. You can say I is equal to what? IZ plus IL. I, that incoming current, is divided into two parts, IZ plus IL. From this formula, what is the IZ? I minus IL. I minus IL, this is the equation. Now, apply your FT. When this current will be minimum, IZ minimum means when this incoming current is minimum or at the same time maximum load current is required. When it will send the minimum current or at the same time load will require the maximum. So I minimum minus IL maximum will give you the least difference. IZ minimum. If the IZ minimum, so you are giving the Nandesh D option na 24.2. Right. That is the wrong ones. Why wrong? You will get the idea. I minimum minus IL maximum. This current should be greater than IZK. Why it should be greater than IZK? If this is the minimum Zener diode current is less than the knee current, then Zener diode is not in breakdown region. If it is not in breakdown region, circuit will not work. Circuit will not work. That's why the minimum Zener diode current should be greater than the knee current. And what is the knee current? 0.5 milliampere. And when will be the minimum knee current? When it will send the minimum current, it will require the maximum current. Now how we can write the minimum current? VI minimum minus VZ upon R. This is the R. When this is minimum, this is fixed. It will provide the minimum current. And out of this minimum, it will take the maximum current because we have to find the maximum IL. This current should be greater than or equal to knee current. Now tell me, you can say IL maximum should be less than or equal to VI minimum minus VZ upon R minus 0.5. Put the value 20 minus 5.8 upon 1 kilo ohm minus 0.5. That is nothing but 14.2 minus 0.5, and answer is what? 13.7. Answer is 13.7. Okay, remember, it should be in breakdown region, means that current should be greater than what IZK. So Nandesh, it is clear to you, your answer is wrong. Your in number of books it is given, but this is the wrong answer. No doubt you can get the maximum current for the maximum value of the input, but the circuit will not work. It should be remain in breakdown region. You have to satisfy this condition. This is a very important one. Directly use this formula. No need to check anything. Directly use this formula. IZ minimum, I minimum minus IL maximum, that should be greater than or equal to IZK. Okay, tell me, how many students want this type of sessions? So that you will get the idea what is your weakness, what is your strength, and how to handle the questions. Because we are dealing with all important subject, guys. Hope you have enjoyed the session. Everyone, please like the session at the end. So I have covered all the topics from the analog, remember. And on the 15th of August, watch one session on what? Mock test for GATE 2024. Okay, so everyone attend that session. And today evening I am going to take what more. This is the important general session within 15 minutes. Within 15 minutes from 7:30 to 7:45. I just want to give you the idea about the mock test. What is the mock test and how to use, how to analyze the mock test, what about the weak and strong points, how to make the short notes, how we are going to start our revision, and then again we have to give the mock test. And because this is the time to start mock test for all exams, whether it is GATE, ESE, HAL, ISRO, and so on. Now, so what is the use? Already we are giving the mock test. So how many number of mock test, timing of the mock test, subject wise or full length mock test, then how many subject wise, how many full length mock test, number of questions are here. Okay, so thank you. Now this is for you. Take a step towards success in GATE exam. You can give the national scholarship test for GATE exam. Get up to 90% off on our program. Please note the date, 13th August. अरे इंडिपेंडेंस डे के पहले आपकी इंडिपेंडेंस हो जाएगी, सही बात है. आइए आप लोग ऑन 13th of August. और विंडो देखो कब से ओपन है, 9 AM to 9 PM फॉर 12 hours. आपके लिए पूरा फ्लेक्सिबल टाइम है. देखिए यहाँ पर दिस इज अ फ्लेक्सिबल टाइम, 9 AM to what 9 PM. अभी इतना तो कभी भी आप टाइम निकाल सकते हैं, जरूर दीजिए. दैट इज अ गोल्डन अपॉर्चुनिटी फॉर यू एंड गेट अप टू 90% ऑफ ऑन आवर प्रोग्राम. ओके, एंड स्टार्ट योर प्रिपरेशन विद अस. देन now if you want to get the idea about GATE 2024, then 5 steps to run in GATE 2024 live interactive workshop by Richa Gupta ma'am, MTech from NIT Raipur, 5+ years of teaching experience, on 16th of August, 7:30 PM, just after the 15th August. Okay, so hope you have enjoyed the session. Thank you very much for attending the session. You are on BYJU'S exam prep, the most comprehensive app for all competitive exams. Thank you and good day.